Hello there, and welcome to Just About Earth, where curiosity slows down, explanations take their time, and science becomes something you can listen to at the end of a long day. Perhaps while the room is dim, the world outside is quiet, and the mind is ready to wander gently. Tonight, we're going to travel back, not hundreds or thousands of years, but millions. We're going to visit a time that doesn't often appear in everyday conversation, a time before cities, before language, before firelight reflected in human eyes. A time when the ancestors of humans were still something else entirely, creatures balanced between worlds, not quite ape as we think of apes today, and not yet human either. This was the Pliocene. It was an era when the planet looked familiar at a glance but felt very different once you stayed a while. The oceans were in roughly the same places. Continents were close to where they sit today. Yet the air was warmer, the forests and grasslands were shifting, and in parts of Africa small groups of upright walking primates were beginning to explore a new way of living on the ground. It's easy to imagine evolution as a sudden transformation, a dramatic leap from one form to another, as if one morning a creature woke up and found itself human. But the truth is quieter than that. Change happened slowly, across countless generations, in small adjustments so subtle that no individual would ever notice them. A slightly different way of walking, a slightly different shape of tooth, a slightly different way of using the hands, and over time those tiny differences accumulated until the world contained beings that had never existed before. Before we go further, let me ask you something gentle to think about, something that connects your moment to this long story. Where are you listening from tonight? Are you in a city apartment with distant traffic murmuring beyond the walls? Perhaps you're in a quieter place, where the night air carries only the faint sounds of wind or insects. And what time is it for you right now? Late evening? Early morning? Somewhere in between, when the day hasn't fully decided what it wants to be yet? It's a curious thing, isn't it, that we can sit in our own small spaces, separated by oceans and continents, and yet share a journey into a world that vanished millions of years ago. If you find this kind of slow exploration soothing or interesting, or simply a pleasant way to unwind, I'd be grateful if you liked the video and perhaps subscribed. It helps this quiet corner of science reach others who might enjoy drifting off while learning about the deep past. But for now, there's nothing to do, nowhere to hurry. Just listen and let the mind follow along at its own pace. So, let's begin. Imagine, for a moment, standing in Africa around 4 million years ago. The air is warm, warmer than most places on Earth today. Horizon stretches wide, broken by clusters of trees and long expanses of grass. The landscape is neither dense jungle nor open desert, but something in between, a mosaic of woodland, river valleys and grassy plains. In the distance, a herd of antelope-like animals moves slowly, pausing now and then to graze. Birds circle overhead, riding invisible currents of warm air. Somewhere nearby, hidden in a patch of trees, a small group of primates watches quietly. They are not monkeys, and they are not apes exactly as we know them now. They walk upright more often than their ancestors did, though not as effortlessly as modern humans. Their arms are still long, their faces still somewhat projecting, their brains still modest in size. Yet something about them is different. They're experimenting, in a sense, with a new way of being. For tens of millions of years before this moment, the ancestors of apes lived primarily in forests. Trees provided food, safety, and a three-dimensional world of branches and leaves. Movement meant climbing, swinging, balancing. The ground below was dangerous, a place where predators prowled and shelter was scarce. But the Pliocene was a time of change, and those changes were reshaping the habitats of Africa in subtle but powerful ways. Forests were retreating in some regions, replaced by more open landscapes. Rainfall patterns were shifting. Temperatures were fluctuating over long cycles. The world was not becoming hostile exactly, but it was becoming unpredictable, and unpredictability has a way of favouring flexibility. Some primates began spending more time on the ground, travelling between patches of trees, foraging in new ways, adapting to new risks. Walking upright, which had once been occasional, started to matter more. Standing on two legs freed the hands. It changed how energy was used while moving long distances. It raised the head, allowing a clearer view over tall grass. None of these advantages transformed life overnight, but together, over thousands of generations, they nudged evolution in a particular direction. What's fascinating is that these changes were not guided by any plan. There was no destination waiting, no predetermined future in which humans would eventually appear. There were only pressures, opportunities, and countless small variations, each one tested by the quiet, persistent filter of survival. And yet, from those ordinary processes, something extraordinary was beginning. It's worth pausing here to consider how deep this history really is. 4 million years is such a large span of time that the mind struggles to picture it. If you compressed all of human civilization, the pyramids, the Roman Empire, the invention of writing, the entire modern world, into a single hour, the Pliocene would stretch back for weeks before that hour even began. The individuals living then had no sense of being at the beginning of anything. They woke, searched for food, cared for their young, avoided danger, rested at night. Their lives were immediate, practical, grounded in the present moment, just as ours are in many ways. And yet, unknowingly, they were part of a story that would one day lead to us. There's something quietly humbling about that thought. Every step you take, every breath, every small routine of daily life exists because of an unbroken chain of survival, stretching back through the Pliocene, through earlier epochs, through creatures that lived and died without ever imagining what would come after them. Sometimes people imagine evolution as a ladder, with humans at the top, as if the entire process were aimed at producing us. But evolution is more like a branching tree, with countless paths, most of which lead nowhere in particular, and only a few continuing onward. In the Pliocene, many different kinds of hominins existed, experimenting in different ways with upright walking, different diets, different habitats. Some would leave descendants, others would vanish, their stories preserved only in fragments of bone buried in ancient sediments. Even today, scientists continue to piece together those fragments, carefully brushing dust from fossils, studying the shapes of teeth and joints, reconstructing entire lives from the smallest clues. A single footprint, preserved in volcanic ash, can reveal how a creature walked. A worn molar can hint at what it ate. The thickness of a bone can tell us how weight was carried, how muscles were used, how bodies moved through their environment. It's a kind of detective work, but one conducted across millions of years, and perhaps that's part of what makes this period so compelling. The Pliocene is close enough to feel connected to us, yet distant enough to feel almost dreamlike. The world was recognizable, but quieter, slower, less crowded. No engines, no cities, no electric light. Only wind moving through grass, water flowing in rivers, the distant calls of animals at dusk. If you let yourself imagine it for a moment, you can almost hear it. Not silence exactly, but a different kind of soundscape. The rustle of leaves, the chirping of insects, the occasional crack of a branch as something moves unseen in the trees. And somewhere in that landscape, small groups of early hominins are learning, adapting, surviving, not through strength or speed, but through flexibility, awareness, and cooperation. Those qualities, more than anything else, would shape the future. It's interesting to reflect on how fragile that future was at the time. A slightly harsher climate shift, a different pattern of rainfall, a change in predator populations. any of these could have altered the course of evolution in ways that might have prevented our lineage from continuing. The existence of humans was never guaranteed. In fact, if you could return to the Pliocene and look around, you probably wouldn't pick our ancestors as the most likely candidates for global dominance. They were small, relatively slow, lacking claws or fangs, vulnerable in many ways, but they had something subtle and powerful: adaptability. They could change their behaviour, adjust their diets, move into new environments, learn from experience. These traits may not seem dramatic, but over long periods of time, they become incredibly significant. Adaptability, after all, is what allows life to persist in a changing world. As the Pliocene unfolded, those changes were becoming more pronounced. The climate was cooling gradually compared to earlier epochs, though still warmer than today. Ice sheets were beginning to expand in polar regions. Ocean currents were shifting. Seasonal patterns were becoming more variable. These changes didn't happen overnight. They unfolded slowly, over hundreds of thousands of years, shaping landscapes and ecosystems in ways that would influence the course of evolution. And that's where our journey naturally begins to move next. Because to understand why early hominins began to change, to walk more, to explore more, to adapt in new ways, we need to understand the world they lived in. What was the climate of the Pliocene really like? How warm was it? How stable or unstable? And how did those conditions shape the environments where our ancestors took their first steps toward becoming something new? Long before thermometers, satellites or weather forecasts existed, the Earth kept its own quiet records of climate. Those records were written in layers of sediment at the bottom of oceans, in microscopic shells, in trapped bubbles of ancient air, and in the slow advance and retreat of ice. Today, scientists read those records carefully, piecing together a picture of the Pliocene climate, and what they find is both familiar and surprising. To begin with, the Pliocene was warmer than the world we know now. Not unimaginably hot, not a steaming jungle from pole to pole, but noticeably warmer, especially in higher latitudes. Average global temperatures were likely about 2 to 4 degrees Celsius higher than today. That might not sound like much at first, but on a planetary scale it's a substantial difference, enough to reshape coastlines, ecosystems, and the patterns of life across continents. One of the clearest signs of this warmth was the level of the seas. During parts of the Pliocene, sea level stood perhaps 10 to 20 metres higher than modern levels. That meant shorelines looked different. Many areas that are now coastal plains or river deltas lay underwater, and shallow seas reached farther inland in some regions. Entire stretches of land that people now walk across did not yet exist as dry ground. It's strange to imagine familiar places submerged beneath gentle, warm waves, but the Earth has done this many times in its history. Coastlines, after all, are temporary things, drawn and erased over millions of years as ice sheets grow and shrink, as water expands and contracts, as continents shift ever so slowly. What made the Pliocene especially interesting, though, wasn't just that it was warm. It was that the warmth was unevenly distributed. Polar regions were much warmer relative to today than tropical regions were. Forests extended farther north. Areas that are now tundra supported trees and shrubs. The Arctic, though not ice-free year-round, had far less permanent ice than it does today. That difference in temperature between equator and poles plays an important role in how winds and ocean currents behave. When the poles are warmer, the gradients that drive atmospheric circulation shift. Rainfall patterns change, storm tracks move, regions that are wet may become drier, and dry regions may receive more seasonal rains. And those shifts matter deeply for life on land. In Africa, where many early hominins lived, the climate of the Pliocene was not simply warm and stable. It fluctuated. Periods of wetter conditions alternated with drier ones. Forests expanded and contracted. Grasslands spread, then retreated, then spread again. Imagine living in a landscape where the environment is slowly, repeatedly changing over thousands of years, not quickly enough to notice in a single lifetime, but steadily enough that each generation grows up in a world slightly different from the one their grandparents knew. That kind of gradual instability favours creatures that can adapt. Animals specialised for one narrow type of habitat often struggle when conditions shift, but animals that can exploit different foods, move across different terrains, or adjust their behaviour have an advantage. Flexibility becomes more valuable than perfection. This is one of the reasons the Pliocene climate is so important in the story of human evolution. It didn't simply provide a warm backdrop, it created a dynamic, changing stage on which adaptability mattered more and more. Scientists have learned a great deal about this climate by studying tiny fossils called foraminifera, microscopic marine organisms that build shells from calcium carbonate. The ratio of oxygen isotopes in those shells changes depending on the temperature of the water in which they formed. By analysing layers of these shells in ocean sediments, researchers can reconstruct temperature patterns stretching back millions of years. It's remarkable to think that creatures smaller than grains of sand can tell us about the temperature of ancient oceans. But that's how much of paleoclimate science works. Small clues, carefully interpreted, revealing vast stories. Another source of information comes from fossilised pollen. Different plants produce distinctive pollen grains, and those grains can persist in sediments for millions of years. By examining the types of pollen in ancient deposits, scientists can infer what kinds of vegetation once grew in a region, and from that, deduce the climate conditions that supported it. In parts of East Africa, pollen records show a mix of woodland and grassland species during the Pliocene, suggesting landscapes that were patchy and varied rather than uniformly forested or open. That patchiness would have created a mosaic of habitats, offering both challenges and opportunities for animals moving through them. It's not difficult to imagine how such landscapes might shape behaviour. Travelling between patches of trees would require time spent on the ground. Finding food might involve covering longer distances. Avoiding predators might depend on being able to see over tall grass or move efficiently across open terrain. Gradually, step by step, such pressures can shape anatomy and behaviour. There's another aspect of the Pliocene climate that often surprises people. Despite being warmer overall, it was also a time when the Earth was slowly heading toward the ice ages of the Pleistocene. Large ice sheets were beginning to form in Greenland, and Antarctica already held substantial ice. So the Pliocene was not simply a warm, stable plateau. It was a transitional time, balanced between warmth and the gradual cooling that would come later. One of the key events influencing global climate during this period was the closing of the Isthmus of Panama. As the North and South American continents drifted closer together, the seaway that once connected the Pacific and Atlantic Oceans narrowed and eventually closed. This altered ocean currents on a global scale, strengthening the Gulf Stream and changing patterns of heat transport. Ocean currents are sometimes described as the planet's circulatory system, carrying warm water from the tropics toward higher latitudes and returning cooler water toward the equator. When those currents shift, climate patterns across entire continents can change. The closing of the Panamanian Seaway may have contributed to increased moisture transport to higher latitudes, which in turn supported the growth of ice sheets. It's a reminder that even geological changes far from Africa could influence the conditions under which early hominins lived. Climate, after all, is a global system, interconnected in ways that aren't always obvious. At the same time, tectonic forces were continuing to shape the East African Rift, a vast system of valleys and uplifts stretching thousands of kilometres. As land rose and fell, it altered rainfall patterns and created varied landscapes, lakes, wetlands, forests, and open plains existing side by side. These varied environments provided niches for many different species. Some thrived in forests, others adapted to grasslands, still others moved between habitats, taking advantage of seasonal changes. Early hominins appear to have been among those flexible inhabitants, capable of using both wooded and open areas. Fossil evidence suggests they were not strictly forest dwellers, nor fully open country specialists, but something in between. That in-between existence may have been crucial. Living at the edge of multiple environments requires awareness and adaptability. It means coping with changing food sources, shifting risks, and unpredictable weather. Over time, these pressures can encourage traits like endurance walking, versatile diets, and complex social cooperation. Another fascinating detail about the Pliocene climate involves atmospheric carbon dioxide levels. Estimates suggest that CO2 concentrations were similar to, or slightly higher than modern levels in some intervals, perhaps around 350 to 450 parts per million. That range is particularly interesting today because it overlaps with levels humans are now reaching again through industrial emissions. For this reason, scientists often study the Pliocene as a kind of natural experiment, a glimpse of how Earth systems respond to higher greenhouse gas concentrations over long timescales. Of course, the world of the Pliocene was different in many ways. Continental positions, ocean gateways, and ecosystems were not identical to those of today. Still, the parallels offer valuable insights into how temperature, ice, and sea level interact. But while these global patterns are important, it's also worth remembering that climate is experienced locally. A change in average global temperature of a few degrees translates into very different daily experiences depending on where you are. In some regions, it might mean longer dry seasons. In others, more intense rains. In still others, gradual shifts in vegetation that change what animals eat and where they travel. For the small groups of early hominins living in Africa, climate was not an abstract concept. It was the difference between a reliable water source and a dry riverbed, between abundant fruit and scarce roots, between safety in trees and exposure on open ground. And yet, life persisted. It's easy to picture ancient climates as harsh or unforgiving, but the Pliocene was, in many ways, a productive and vibrant time. Grasslands supported large herds of grazing animals. Rivers and lakes provided water and food. Forest patches offered shelter and resources. The world was not empty or silent. It was full of life, moving, feeding, adapting. Predators stalked the plains, big cats, hyenas, crocodiles near waterways. Herbivores grazed in groups. Birds nested, insects hummed, plants flowered and set seed in seasonal rhythms much like those we see today. And among all that life, small groups of upright walking primates continued their quiet experiment in survival. One of the most intriguing aspects of climate-driven evolution is that the pressure is rarely dramatic in the short term. There are no sudden announcements, no clear turning points visible to those living through it. Instead, there is a gradual accumulation of small challenges and opportunities, a slightly longer dry season here, a slightly more open landscape there, a gradual shift in the distribution of plants. Over thousands of generations, these small differences can shape bodies and behaviours in profound ways. It's also worth considering how slow these changes were from a human perspective. 1,000 years, which feels unimaginably long in terms of human history, is only a brief moment in evolutionary time. Climate shifts in the Pliocene often unfolded over tens or hundreds of thousands of years, allowing populations time to adapt, migrate, or gradually change. That slow pace is part of why evolution works at all. Rapid, catastrophic changes can cause extinctions, but gradual changes create pathways for adaptation, and the Pliocene provided many such pathways. To understand how life unfolded during the Pliocene, it helps to picture not only the climate, but the shape of the world itself. Temperature and rainfall set the conditions, but geography determines how those conditions are distributed, how rivers flow, where mountains rise, and how populations of animals become connected or separated over long stretches of time. The Earth of the Pliocene was, in broad outline, recognisable. The continents were already close to their modern positions. The Atlantic Ocean had widened much as it has today. Africa, Europe, Asia, the Americas, Antarctica, and Australia were all in roughly the places we would recognise on a globe. And yet, the details were different enough to matter. Sea levels, as mentioned earlier, were often higher. That alone reshaped coastlines across the planet. Low-lying regions that are now dry land were shallow seas or tidal wetlands. In some places, the coastline lay many kilometres inland from where it stands today. River mouths formed broad estuaries, and coastal plains that now support cities, farms or forests simply did not exist. Imagine looking at a familiar map and then slowly letting the ocean rise, covering valleys and plains, turning peninsulas into islands and islands into reefs. The outlines would shift, but the larger shapes of continents would remain, like a face seen from a slightly different angle. These shifting shorelines influenced the movement of animals and the distribution of ecosystems. Coastal habitats expanded in some regions, offering new feeding grounds for birds and marine life. Inland, changes in drainage patterns altered where lakes formed and how rivers carved their paths. But geography during the Pliocene was shaped by more than water alone. Beneath the surface, the slow forces of plate tectonics continued their patient work, lifting land here, lowering it there, and gradually rearranging the details of the planet's surface. One of the most significant geological features influencing early human evolution was the East African Rift System. This immense series of valleys and fault lines, stretching thousands of kilometres, was already well developed during the Pliocene. The land there was not static. It was, and still is, slowly pulling apart, creating basins, escarpments, and chains of lakes. If you could stand on a high ridge in that region 4 million years ago, the view might remind you of parts of East Africa today. Broad valleys dotted with lakes, volcanic highlands in the distance, and landscapes that change dramatically over relatively short distances. These variations in elevation and terrain created a patchwork of environments. Rainfall patterns differed from one valley to the next. Some areas supported woodlands, others grasslands, others wetlands rich in plant and animal life. For early hominins, such diversity of habitats meant options. A population living near a lake might rely on different food sources than one living on drier plains. Groups separated by ridges or valleys might gradually diverge, adapting to slightly different conditions over many generations. Geography, in this sense, can act as a quiet engine of evolution, guiding populations along different paths without any sudden or dramatic event. Volcanic activity also played a role in shaping these landscapes. The rift system was, and remains, geologically active. Volcanoes rose, erupted, and eroded over long spans of time. Layers of volcanic ash settled across wide areas, sometimes preserving footprints and other traces of life in remarkable detail. One of the most famous examples, though slightly later than the early Pliocene, comes from Litoli in Tanzania, where footprints preserved in ancient ash reveal the gait of upright walking hominins. Such moments, frozen in stone, give us rare glimpses into the daily movements of creatures who left few other traces. Volcanoes, of course, were not gentle neighbours. Eruptions could devastate local ecosystems, but over longer periods, volcanic soils often became fertile, supporting abundant vegetation once the ash settled and weathered. So even destructive forces could, in time, create opportunities for life to return and flourish. Beyond Africa, other parts of the world were also undergoing geographic changes that would influence global patterns of climate and life. The closing of the Isthmus of Panama, which we touched on earlier, was not just a climatic event but a geographic one of immense importance. Before the isthmus fully formed, the Atlantic and Pacific Oceans were connected by a broad seaway. Marine species could move freely between them, and ocean currents followed different routes than they do today. As the land bridge rose, it divided those oceans, altering currents and triggering what is known as the Great American Biotic Interchange. Animals that had evolved separately in North and South America began to migrate across the new land connection. Armadillos and opossums moved northward. Horses, cats and bears moved southward. Entire ecosystems were reshaped by these migrations, as species encountered new competitors predators and prey. While this interchange occurred far from Africa, it illustrates how geographic changes in one region can ripple across the planet, influencing climate, ocean circulation, and the distribution of life. Another significant geographic feature of the Pliocene was Antarctica. By this time, the continent was already covered in extensive ice sheets, though their size fluctuated. The presence of that ice played a major role in regulating global climate, reflecting sunlight and influencing ocean circulation patterns. Greenland too was beginning to accumulate substantial ice. These northern ice sheets were not yet as vast as they would become during the later ice ages, but their growth marked an important step toward the cooler climates that would follow. It's interesting to consider how the geography of ice, just like the geography of land and sea, shapes the world in profound ways. Ice sheets alter sea levels, redirect winds, and even influence the chemistry of the oceans. Meanwhile, in Eurasia, mountain ranges such as the Himalayas continued to rise slowly, the result of the Indian subcontinent pressing into Asia. This uplift affected atmospheric circulation, strengthening monsoon systems and altering rainfall patterns across vast regions. Mountains are often thought of as permanent features, but in geological terms they are temporary, rising and eroding, reshaped by forces that operate over millions of years. All of these geographic processes, the shifting of continents, the rise of mountains, the formation of rift valleys, the opening and closing of seaways, created a world that was dynamic, not static. And within that dynamic world, ecosystems formed and reformed in response to changing conditions. Returning to Africa, the geography of lakes during the Pliocene deserves special attention. Large lakes periodically filled many of the rift valleys, expanding and shrinking with climate cycles. These lakes were rich environments supporting fish, birds, and a variety of plant life. For animals living nearby, lakes provided reliable water sources, which in turn attracted prey and predators alike. They were hubs of activity, places where different species crossed paths. It's not difficult to imagine early hominins visiting such lake shores, foraging for food, drinking, or simply passing through as part of their seasonal movements. Waterways also acted as natural corridors, guiding the movements of animals across the landscape. Rivers cut through plains and woodlands, linking distant regions and providing routes for migration. At the same time, geographic barriers could isolate populations. A widening valley, a new lake, or a stretch of unsuitable habitat could separate groups long enough for them to evolve in different directions. Isolation and reconnection, separation and migration. These patterns repeated again and again, shaping the diversity of life. One subtle but important aspect of geography is how it influences vegetation. Soil types, elevation, and drainage patterns all affect what plants can grow in a particular place. And plants, in turn, determine what herbivores can eat, which predators can hunt there, and how entire ecosystems are structured. In parts of the Pliocene world, the spread of grasslands was closely tied to geographic factors such as rainfall shadows created by mountains or the seasonal flooding of plains. Grasslands supported grazing animals, and grazing animals supported predators, creating new ecological relationships. For early hominins, these shifting environments meant adapting not only to climate, but to the changing availability of food and shelter. It's easy to think of geography as something fixed and unchanging, but in reality the surface of the Earth is always in motion, even if that motion is too slow to notice in a human lifetime. Rivers change course, lakes appear and vanish, coastlines advance and retreat. Forests give way to grasslands, and grasslands may one day return to forest. Over millions of years these changes accumulate, creating landscapes very different from those that came before. Another intriguing feature of the Pliocene world was the distribution of deserts. Some regions that are arid today were less so, while others experienced cycles of drying and wetting. The Sahara, for example, has gone through many phases, sometimes supporting lakes, rivers, and abundant wildlife, and at other times becoming the vast desert we know now. These cycles of environmental change would have influenced the movements of animals, including early hominins, encouraging migration during wetter periods and constraining populations during drier ones. Migration itself is a powerful evolutionary force. When populations move into new environments, they encounter new challenges and opportunities, and over time, natural selection shapes them accordingly. All of this reminds us that the story of human evolution is not only about biology, it is also about geology, climate, and geography working together, slowly shaping the conditions in which life unfolds. The early hominins of the Pliocene were not simply evolving in isolation. They were part of a complex, ever-changing world, responding to landscapes that shifted over generations, to coastlines that moved, to forests that expanded and contracted. And through it all, life continued, adapting step by step. If you pause for a moment and think about it, every place you know today, every city, forest, and coastline, is only a temporary arrangement. Given enough time, the earth will reshape it all. Mountains will erode, seas will advance or retreat, new valleys will form where none existed before. The world of the Pliocene is a reminder of that quiet, persistent change. If you could drift slowly above East Africa during the Pliocene, watching the land unfold beneath you as the sun moved across the sky, one of the first things you would notice is variety. The ground below would not appear as one endless forest or one continuous plain. Instead, the landscape would look like a patchwork. Clusters of trees, open grasslands, winding rivers, scattered woodlands, and in some places wide stretches of savannah reaching toward the horizon. This mixture of environments is important, because the story of early human evolution did not happen in a single type of habitat. It happened in places where environments met, overlapped, and changed. To understand why, it helps to begin with forests, because for tens of millions of years before the Pliocene, forests had been home to the ancestors of apes. Dense canopies provided food in the form of fruits, leaves, and insects. Branches offered pathways through the air, allowing movement without descending to the ground, where predators were more numerous and dangers less predictable. Living in trees shaped bodies in very specific ways. Arms became long and strong for climbing and swinging. Hands developed flexible fingers capable of grasping branches securely. Vision became more forward-facing, allowing precise judgment of distance while moving through complex three-dimensional spaces. These traits did not disappear during the Pliocene. Many early hominins still retained them, and fossil evidence suggests that some species continue to climb trees regularly, perhaps to sleep safely at night or to gather food that remained available in wooded areas. But forests were no longer as widespread as they had once been. Climate changes and shifting rainfall patterns gradually reduced continuous forest cover in many parts of Africa. Instead of vast, unbroken jungles, the land increasingly supported mosaic environments where woodland patches alternated with more open terrain. This change did not happen suddenly. Over thousands of years, trees retreated from some areas, grasses spread into others, and landscapes that had once been shaded and enclosed became brighter, warmer, and more exposed. Grasses themselves are remarkable plants. They are well adapted to dry seasons, grazing animals, and even fire. Unlike many trees, grasses can regrow quickly after being eaten or burned, and their root systems often survive beneath the soil even when the surface vegetation is removed. As grasslands expanded, they brought with them entire communities of animals adapted to grazing. Antelopes, early zebras, and other herbivores capable of feeding on tough fibrous plants. These animals in turn supported predators that specialized in hunting on open ground. So the expansion of grasslands did not simply change the scenery, it reshaped entire food webs. For primates accustomed to forest life, these new environments presented both risks and opportunities. On the one hand, open areas meant greater exposure to predators and fewer trees to climb quickly for safety. On the other hand, grasslands offered new food sources, new routes for travel, and new ecological niches that fewer competitors occupied. Some primates remained in forests and continued living much as their ancestors had. Others began venturing more frequently onto the ground, moving between tree clusters, exploring the edges of grasslands, adapting gradually to conditions that were quite different from those of deep forest habitats. It is within these transitional zones, the borders between woodland and open plain, that many early hominins seem to have lived. These areas provided access to both worlds. Trees still offered refuge and food, while open ground allowed movement across larger territories. Seasonal changes might have encouraged groups to shift their foraging patterns, spending more time in one environment during certain months and in another during different times of year. Living in such varied landscapes required flexibility. Diets could not depend entirely on one type of food. Movement patterns had to adjust to changing conditions. Awareness of predators needed to extend beyond the immediate surroundings, because dangers in open terrain could approach from greater distances. Over long periods of time, these pressures favoured individuals capable of moving efficiently on the ground. Walking upright, which may have begun earlier for reasons still debated by scientists, became increasingly useful in such environments. Standing on two legs reduces the amount of body surface exposed directly to the midday sun, improves long-distance visibility, and frees the hands for carrying food or other objects. None of these advantages alone would have transformed a species overnight, but together they could gradually shift the balance in favour of more frequent bipedal movement. Meanwhile, the savannah itself was not the uniform, treeless plain people sometimes imagine. The word savannah often brings to mind endless grass stretching to the horizon, but in reality many savannah landscapes include scattered trees, shrubs, and seasonal water sources. These environments are dynamic. Grasses grow rapidly during wet seasons, then dry and wither during dry periods. Fires, sparked by lightning or other natural causes, sweep across the land, clearing old vegetation and allowing new growth to emerge. Fire, in particular, plays an important ecological role in savanna systems. Many grasses are adapted to survive burning, and periodic fires prevent forests from reclaiming open areas too quickly. In this way, fire helps maintain the balance between woodland and grassland. For animals living in these regions, the rhythms of wet and dry seasons shaped daily life. Waterholes filled and shrank. Herds migrated in search of fresh grazing. Predators followed prey, and scavengers followed predators. Early hominins living in such landscapes would have been part of this seasonal cycle, adjusting their movements and behaviour in response to changing conditions. One useful way to picture these environments is to imagine walking through them slowly. In the early morning, the air is cool and dew clings to blades of grass. Birds call from scattered trees, and distant shapes of grazing animals move through the mist. As the sun rises, the temperature climbs. Insects become more active. The scent of warm earth and dry vegetation drifts on the breeze. Shade becomes valuable, and animals seek shelter during the hottest hours. By late afternoon, the light softens. Activity resumes. The sounds of movement return. Footsteps in grass, wings beating overhead, the distant call of animals settling for the evening. Night brings a different world entirely, one filled with unfamiliar sounds, cooler air, and predators whose senses are adapted to darkness. Living in such a place requires constant awareness. Every sound, every scent, every movement in the grass can carry meaning. For early hominins, cooperation may have been one of the most effective responses to these challenges. Groups could watch for danger collectively, share information about food sources, and protect vulnerable members such as infants. Social behaviour, already present in earlier primates, likely became even more important in open environments where individual vulnerability was greater. Another feature of savanna landscapes that influenced evolution was the need to travel longer distances between resources. In dense forests, food may be abundant within relatively small areas. In more open environments, useful plants, water and shelter can be scattered across wider territories. Efficient walking becomes valuable under such conditions. Energy conservation matters. Individuals capable of covering ground steadily without overheating or exhausting themselves would have had an advantage. Over many generations, small anatomical changes supporting upright walking, changes in the shape of the pelvis, the curvature of the spine, the structure of the feet, became more pronounced. At the same time, early hominins did not abandon trees entirely. Fossil evidence suggests that many species retained curved fingers and other features associated with climbing. Their lives were not confined to one environment, but spanned multiple habitats. This combination of abilities, walking on the ground and climbing when necessary, may have been one of their greatest strengths. Vegetation during the Pliocene also differed in composition from modern ecosystems. Some plant species that existed then are now extinct, while others have persisted with relatively little change. Grass species, in particular, underwent important evolutionary developments during this time, including the spread of grasses using what is known as C4 photosynthesis, a more efficient process in warm, dry conditions. These grasses became widespread in tropical and subtropical regions, supporting large populations of grazing animals and reinforcing the expansion of savanna ecosystems. The spread of grasslands is sometimes described as one of the key environmental changes influencing human evolution. While this idea is broadly true, it is important to remember that the process was gradual and complex. Forests did not simply vanish, nor did grasslands appear everywhere at once. Instead, landscapes shifted repeatedly, expanding and contracting in response to climate cycles, tectonic changes, and ecological interactions. This variability may have been more important than any single environmental state. A stable, unchanging environment tends to favour specialisation. A changing environment rewards adaptability, and adaptability, more than strength or speed, appears again and again as a defining characteristic of the lineage that would eventually lead to humans. It is also worth reflecting on how these landscapes would have looked and felt to the creatures living in them. There were no roads, no fences, no distant glow of cities on the horizon. The night sky would have been brilliant, filled with stars unblurred by artificial light. The sounds of the world would have been those of wind, water, insects, and animals. The scents would have been of earth, grass, and vegetation warming in the sun. For early hominins, the environment was not scenery. It was everything. The source of food, the place of danger, the setting of daily life. Every step taken across a patch of open ground carried meaning. Every tree offered both opportunity and refuge. Every change in season reshaped the possibilities of survival. As time passed, some populations adapted more fully to these conditions. Others remained closer to forested habitats. Evolution does not move in a straight line, and the Pliocene world contained many different hominin species, each exploring its own way of living. Some of those lineages would eventually disappear, leaving no descendants. Others would continue, gradually changing, eventually giving rise to the earliest members of the genus Homo. But at this stage in the story, those future developments were still far away. The world of the Pliocene was still a world of experimentation, of small populations scattered across varied landscapes, each generation facing the same basic challenges: finding food, avoiding predators, raising young, and surviving long enough to pass on their genes. The forests had not vanished. The grasslands were still spreading. The savannas were becoming more prominent, shaping the movements and behaviours of countless species, and among those species were the early hominins, walking sometimes on two legs, sometimes climbing, living in environments that demanded awareness, cooperation, and flexibility. Long before the first clear signs of upright walking hominins appeared on the African landscape, the world already belonged to apes. They were not rare or experimental creatures at that point in time. They were a successful and diverse group, spread across forests and woodlands, shaped by millions of years of evolution in environments where climbing, grasping, and careful movement through branches determined survival. To picture them, it helps to let go of the idea that the past contained only the animals we see today. The great apes of the Pliocene were not exactly like modern chimpanzees, gorillas, or orangutans, although they shared many traits. Some species resembled modern apes in certain ways, while others had combinations of features that no longer exist. Evolution had not yet narrowed the possibilities. There was still a broad diversity of forms, some adapted to dense forests, others to more open woodlands, and still others occupying ecological niches that would later vanish. Their world, as we have already begun to see, was changing. Forests were no longer continuous across vast regions. Open areas were expanding. Seasonal variation was becoming more pronounced. But before those changes fully reshaped the course of evolution, it is worth lingering for a while with the apes themselves, because understanding who they were helps explain why some populations began to change in ways that eventually led toward humans. Most apes of that time were superb climbers. Their shoulders were structured to allow a wide range of motion, useful for reaching overhead branches. Their hands were long-fingered and powerful, capable of gripping with remarkable precision. Their feet too were often adapted for grasping, functioning almost like a second pair of hands when moving through trees. If you imagine moving through a forest canopy, carefully placing each limb, testing each branch before shifting your weight, you begin to sense how different that mode of life is from walking on the ground. Balance, flexibility, and awareness of three-dimensional space become essential. Every movement must be deliberate. Life in trees also shaped social behaviour. Many apes lived in small groups or loose communities, communicating through vocalizations, facial expressions, and gestures. Bonds between individuals mattered, not only for cooperation but for raising young, which in apes require long periods of care and learning. That long childhood, already present in early apes, would later become one of the defining characteristics of humans. Learning complex behaviours takes time, and species that invest in learning often evolve larger brains and more intricate social systems. But in the Pliocene, these processes were still unfolding, not yet obvious in the fossil record, but quietly underway. Diet among great apes varied widely. Fruits were often a major component, supplemented by leaves, seeds, insects, and occasionally small animals. The availability of these foods depended heavily on the season and the structure of the forest. A fruiting tree might provide abundant nourishment for a short period, then nothing for months. This unpredictability encouraged memory and spatial awareness. Knowing where food sources were located, when they would ripen, and how to travel efficiently between them could make the difference between thriving and merely surviving. Even today, studies of modern chimpanzees and other apes reveal impressive mental maps of their territories, built through experience and shared knowledge. It is reasonable to think that their ancestors in the Pliocene possessed similar abilities, navigating landscapes that were often more complex than they first appeared. But the forests were not entirely safe havens. Predators could climb as well. Leopards, for example, have long been capable of pursuing prey into trees. Snakes, birds of prey, and other dangers added to the risks of life in the canopy. So apes lived in a balance of opportunity and caution, much as animals do today. Every environment offers both. What makes this period so intriguing is that some populations of apes began to spend more time on the ground. This was not entirely new behaviour. Even modern chimpanzees descend to the forest floor regularly, travelling, foraging or resting there. The difference in the Pliocene was that ground-based activity gradually became more frequent in certain environments. Woodlands and patchy forests required movement between tree clusters. Food sources were sometimes scattered. Seasonal changes could alter which areas were most productive. Under these conditions, individuals capable of travelling efficiently on the ground gained small advantages. At first, these changes would have been subtle, a slightly different gait. a tendency to stand upright more often while scanning the surroundings, a shift in how weight was distributed through the hips and legs. No single generation would have noticed anything remarkable. Evolution rarely announces itself. It works quietly, through small variations that accumulate over immense spans of time. It is also important to remember that not all apes were moving in the same direction. Many continue to thrive in forest environments, following evolutionary paths that would eventually lead to modern chimpanzees, gorillas, and other species. The lineage that led toward humans was only one branch among many, and at the time, there was nothing inevitable about its success. If anything, it may have seemed an unlikely path. Ground-dwelling primates were exposed, relatively slow, and lacking the formidable teeth or claws of many predators. Survival required vigilance, cooperation, and perhaps a willingness to exploit resources that other animals ignored. Another aspect of ape life that shaped future evolution was the use of hands. Even before the earliest stone tools appear in the archaeological record, apes were already skilled manipulators of objects. Modern chimpanzees use sticks to extract insects, stones to crack nuts, and leaves as sponges to collect water. These behaviours are learned, shared within groups, and sometimes vary from one population to another. It is possible that similar behaviours existed among Pliocene apes, although such activities rarely leave direct fossil evidence. Organic tools decay, and simple actions like breaking branches or digging in soil vanish without trace. Still, the anatomy of the hands tells part of the story. Flexible fingers, sensitive fingertips, and strong thumbs provided the physical foundation for later technological developments, even if the individuals who possessed those traits had no concept of tools in the way humans think of them today. Vision, too, played a crucial role. Forward-facing eyes allowed precise depth perception, essential for navigating branches but equally useful for judging distances on the ground. Colour vision helped in identifying ripe fruits and young leaves, and perhaps also in reading social cues through facial expressions and body language. Communication among apes was already complex. Vocal calls conveyed warnings, contact, and emotional states. Gestures and postures added layers of meaning. Social hierarchies, alliances, and rivalries formed intricate networks within groups. All of these traits, manual dexterity, social complexity, learning ability, flexible diets, were already present to some degree before the first clear hominins appeared. Evolution did not create these characteristics from nothing. It modified and extended what was already there. The Pliocene, in that sense, was not the beginning of the story, but a turning point within a much longer narrative. Another factor influencing ape populations was competition. Forests and woodlands supported many species of primates, each with its own preferred foods and behaviours. As environments shifted, these species sometimes found themselves competing more directly for resources. Competition can drive change by favouring individuals capable of exploiting new foods or new habitats. A population that can survive on a wider variety of plants or travel farther in search of food may gradually outcompete more specialised neighbours. Predation, too, shaped behaviour. On the ground, early apes faced dangers from large cats, hyenas, and other carnivores. Awareness of surroundings, group vigilance, and rapid response to threats would have been essential. Some scientists believed that the need to detect predators in more open environments contributed to the habit of standing upright, at least occasionally. Raising the head above tall grass provides a wider field of view, and over time, behaviours that begin as occasional can become more frequent, eventually influencing anatomy itself. There is something quietly fascinating about how behaviour and anatomy interact in evolution. A change in behaviour can alter selective pressures, favouring anatomical changes that make that behaviour easier or more efficient. In turn, those anatomical changes can encourage further behavioural shifts. Step by step, feedback loops form, guiding populations along new evolutionary paths. Despite all these changes, it is important to imagine the daily lives of these apes as ordinary rather than dramatic. Most days would have been spent searching for food, grooming companions, resting, caring for young, and sleeping. The grand sweep of evolution is built from countless small repetitive actions, not from rare heroic moments. A mother carrying her infant while moving between trees, a group pausing to feed in the shade, individuals watching the movements of animals nearby, listening for unfamiliar sounds, responding to subtle signals from one another. These quiet, unrecorded moments filled the lives of creatures who had no awareness of the future awaiting their distant descendants. Time, as always, moved slowly. Generations followed one another. Small variations appeared in each generation, some fading away, others persisting. Environment shifted, sometimes favouring one set of traits, sometimes another. And gradually, among certain populations, bodies began to change in ways that would later become unmistakable in the fossil record. Pelvis shapes altered to support more efficient upright walking. Legs lengthened relative to arms. Feet became better suited for bearing weight on the ground. Teeth changed in response to new diets. These changes did not appear all at once, and different species exhibited different combinations of traits. The forests had not vanished entirely. The grasslands were still spreading. The world remained a mosaic of habitats, and within that mosaic, populations were experimenting in the quiet, unintentional way that evolution experiments with new ways of moving, feeding, and living. Something subtle began to change among certain populations of primates living in Africa during the late Miocene and continuing into the Pliocene. It was not a dramatic transformation, not a sudden moment when a creature stood upright for the first time and never returned to all fours. Apes had always been capable of standing or walking short distances on two legs. Even today, chimpanzees sometimes carry objects upright or move bipedally for brief moments. But in the Pliocene, in some lineages, walking on two legs began to matter in a new and persistent way. To understand why, it helps to picture the environments we have been exploring. Forests still existed, but they were no longer endless. Woodland patches were separated by stretches of grassland. Food sources were scattered across broader territories. Seasonal changes meant that animals often had to travel farther to find what they needed. In such landscapes, the ability to move efficiently across the ground became increasingly important. Walking on four limbs is effective for many animals, but primates evolved in trees, and their bodies were not originally specialised for long-distance quadrupedal travel on the ground. Their spines, hips, and limb proportions were better suited to climbing and grasping. For these animals, adopting a more upright posture while moving could offer advantages under certain conditions. One of the simplest advantages is visibility. Standing upright raises the head, allowing an individual to see farther over tall grasses or low shrubs. In a landscape where predators could approach from a distance, that extra field of view might mean earlier detection and a better chance of escape. Another advantage involves the hands. When an animal walks on two legs, its hands are free to carry food, transport infants, or manipulate objects. Carrying food back to a safer location rather than consuming it immediately can change social behaviour, encouraging sharing or at least the presence of others during feeding. Energy efficiency also plays a role. Surprisingly, for a creature built to walk upright, bipedal locomotion can be very efficient over long distances. Humans today can walk for hours using relatively little energy compared to many quadrupedal mammals of similar size. Early hominins were not yet as efficient as modern humans, but even partial adaptations toward upright walking may have provided small energetic benefits when travelling between patches of food or water. Of course, advantages rarely come without costs. Walking on two legs places different stresses on the skeleton. The spine must support weight in a new way. The pelvis must stabilise the body with each step. The feet must bear weight and provide propulsion without the support of grasping toes. These challenges required anatomical changes, and those changes did not appear all at once. Instead, the fossil record shows a gradual accumulation of features associated with bipedalism. One of the most important changes occurred in the pelvis. In quadrupedal apes, The pelvis is long and narrow, suited to supporting the trunk while climbing and moving on all fours. In early hominins, the pelvis became shorter and broader, providing a stable base for upright posture and enabling muscles to balance the body during walking. The femur, or thigh bone, also changed. In bipedal walkers, the femur angles inwards slightly from hip to knee, positioning the feet closer to the body's centre of gravity. This alignment helps maintain balance with each step and reduces the side-to-side swaying that would otherwise make upright walking inefficient. The spine developed a gentle S-shaped curve, helping to distribute weight and absorb the impact of walking. The foramen magnum, the opening in the skull where the spinal cord enters, shifted position, moving more centrally beneath the skull. This change reflects a head balanced atop an upright spine, rather than projecting forward as in many quadrupeds. Feet, too, underwent significant transformation. Early apes possessed flexible, grasping feet with opposable big toes, useful for climbing. In more clearly bipedal hominins, the big toe aligned with the others, forming a stable platform for pushing off the ground during walking. The arch of the foot developed gradually, acting as a spring that stores and releases energy with each step. Each of these changes represents a small step in a long process, and different species displayed different combinations of traits. Some early hominins were efficient walkers, but still retained features useful for climbing. Others may have spent more time in trees while occasionally moving bipedally on the ground. This mixture of adaptations reminds us that evolution does not proceed in neat, orderly stages. It produces mosaics, organisms with combinations of old and new features, reflecting transitional ways of life. One of the most compelling pieces of evidence for early bipedalism comes not from bones but from footprints. At Litoli in Tanzania, a set of footprints preserved in volcanic ash records the passage of upright walking hominins roughly 3.6 million years ago. The prints show a clear heel strike and toe-off pattern, much like that of modern human walking. It is an extraordinary thing to look at those footprints because they capture a moment in time. Individuals walking across soft ash, perhaps moving together, leaving impressions that would harden, be buried, and remain hidden for millions of years before being uncovered. Those footsteps are quiet evidence that by the Pliocene, upright walking was not an occasional behaviour, but a regular mode of movement for some hominins. But why did this shift occur? Scientists have proposed many explanations, and it is likely that no single factor tells the whole story. One hypothesis emphasises climate and habitat change, suggesting that expanding grasslands favoured upright walking as hominins spent more time on the ground. Another proposes that bipedalism improved thermoregulation. Standing upright reduces the amount of body surface exposed directly to the sun and raises the body higher into breezes, helping to dissipate heat in hot environments. There is also the possibility that carrying played a role. Individuals able to transport food or other resources might have gained advantages in social interactions or offspring survival. Some researchers suggest that upright posture may even have had social or display functions, allowing individuals to appear larger or more imposing when confronting rivals or predators. It is entirely possible that several of these factors operated together, each contributing a small influence, reinforcing the others over time. What seems clear is that bipedalism did not evolve because of a single dramatic change. It emerged gradually, shaped by multiple pressures acting across many generations. Another important point is that early bipedalism was not identical to modern human walking. The gait of Australopithecines, for example, appears to have been somewhat different, perhaps less efficient over very long distances, but still effective for daily travel. Their bodies were adapted to a mixed lifestyle, combining upright walking with climbing. Long arms and curved fingers suggest that trees still played an important role in their lives, providing refuge or food. This flexibility may have been essential. In a changing world, the ability to exploit multiple habitats can be more valuable than specialization. There is something quietly remarkable about the way such profound changes unfold. No individual ape decided to become upright. No generation noticed the gradual reshaping of bones. Evolution works through differences in survival and reproduction, and those differences are often subtle. A slightly better ability to travel between food sources, a slightly greater chance of spotting danger early, a slightly higher likelihood that offspring survive to adulthood. Over thousands of generations, those small advantages accumulate, reshaping populations in ways that only become obvious when viewed across immense spans of time. It is also worth reflecting on how walking upright changed the relationship between body and environment. When moving on four limbs, the head is oriented forward, close to the ground. Smells, textures, and sounds are experienced differently than when standing upright, with eyes higher and hands free. Bipedalism altered perspective, literally. It allowed early hominins to see the world in a new way, scanning horizons, observing distant movement, navigating landscapes with a different sense of space. Hands freed from locomotion could begin to take on new roles, even before the appearance of formal tools. Carrying, manipulating objects, perhaps using sticks or stones in simple ways. These behaviours may have become more common as upright walking spread. In time, such behaviours would lay the groundwork for technological evolution, but at this stage the changes were still modest, practical, grounded in immediate needs. There is another aspect of bipedalism that often goes unnoticed. Walking upright slows a creature down compared to many quadrupedal animals. Early hominins were unlikely to outrun most predators in a sprint. Survival depended not on speed but on awareness, cooperation, and perhaps endurance. Humans today are remarkable endurance walkers and runners, capable of covering long distances at a steady pace. Some researchers believe that the roots of this endurance may extend back to early hominins, who travelled across open landscapes, moving steadily rather than quickly. In such a lifestyle, patience becomes as important as strength. As the Pliocene progressed, bipedalism became increasingly common among certain hominin species, setting them apart from other apes. Yet they were still far from human in the modern sense. Their brains remained relatively small. Their faces and teeth retained many primitive features. Their lives were shaped more by immediate survival than by complex planning. They were, in many ways, creatures of transition, carrying the legacy of tree-dwelling ancestors while exploring a new way of life on the ground. By the time the Pliocene was well underway, some of the upright walking primates we have been describing were no longer just transitional experiments scattered thinly across the landscape. They had become established populations, living in different regions of Africa, adapting to slightly different environments, and leaving behind fossil remains that would one day allow scientists to recognize them as a distinct group. These were the Australopithecines, a name that simply means southern apes, and they represent some of the earliest creatures we can clearly identify as habitual walkers on two legs. If you were to encounter one of them in the open woodland of East Africa, you might not immediately think of a human ancestor. They were small compared to modern people, many standing little more than a metre tall. Their arms were still relatively long, their faces projected forward more than ours, and their brains were only slightly larger than those of modern chimpanzees. Yet there was something unmistakably different about them, especially in the way they moved. They walked upright, not perfectly as we do today, but well enough that it was their usual way of travelling on the ground. Their footprints, preserved in places like Laetoli, show a stride and balance that leave little doubt about their locomotion. Heel touching first, weight rolling forward, toes pushing off, step after step, much like the motion of a modern human walking along a sandy beach. At the same time, they had not abandoned the trees entirely. Their anatomy suggests that climbing remained part of daily life. Strong arms and curved fingers indicate that they could still move among branches, perhaps to sleep safely at night, or to gather fruits that remained out of reach from the ground. In this way, Australopithecines lived between worlds, equally at home in woodlands and on open ground, adapting to a landscape that demanded versatility. One of the most well-known members of this group is Australopithecus afarensis, the species to which the famous fossil known as Lucy belongs. Discovered in Ethiopia in 1974, Lucy's skeleton provided some of the clearest early evidence of bipedalism. Her pelvis, femur and spine all show adaptations for upright walking, even though her arms remained long and her brain was still small. It is easy to imagine Lucy and others like her moving through a patchwork landscape of grasses and scattered trees, travelling in small groups, stopping to forage, pausing to watch the movements of animals in the distance. Their lives were shaped by the same rhythms that governed other creatures of the Pliocene: seasonal rains, the growth and drying of vegetation, the movements of herds, the presence of predators. Another species, Australopithecus africanus, lived farther south, in regions that are now part of South Africa. Fossils from caves such as Taung and Sterkfontein reveal individuals with similar adaptations for walking upright, along with teeth that suggest a varied diet including fruits, leaves, and possibly tougher plant materials. These different species remind us that evolution is rarely a straight line. Multiple forms existed at the same time, each adapting in its own way. Some lineages persisted for hundreds of thousands of years. Others vanished, leaving only scattered bones and teeth as evidence of their existence. What did daily life look like for Australopithecines? We cannot know with certainty, but we can make careful inferences based on anatomy, environment, and comparisons with modern primates. They likely lived in small groups, as most primates do, because social living offers many advantages. Groups can watch for predators collectively, share information about food sources, and care for young more effectively. Grooming, which in modern primates strengthens social bonds, was probably just as important then as it is now. Infants would have been dependent for long periods, carried by their mothers and gradually learning to move, forage, and interact within the group. Juveniles likely spent time playing, practicing movements and social behaviours that would become essential in adulthood. Food gathering probably occupied much of the day. Fruits, seeds, roots, and leaves would have formed a significant part of the diet, supplemented by insects and possibly small animals. The ability to process a variety of foods was important in environments where availability changed with the seasons. Teeth provide important clues here. Australopithecines had large molars with thick enamel, suitable for grinding tough plant materials. This suggests that when softer foods like ripe fruit were scarce, they could fall back on harder or more fibrous foods that other animals might not exploit as efficiently. This kind of dietary flexibility is often a key factor in survival, especially in changing environments. Predators, of course, were a constant presence. The Pliocene landscape supported large cats, hyenas, crocodiles near waterways, and birds of prey capable of targeting small individuals. Fossil evidence even includes bones of Australopithecines bearing tooth marks from carnivores, a quiet reminder that they were not always the hunters, but often the hunted. Living under such conditions required vigilance. Individuals likely relied on keen hearing, sharp eyesight, and group awareness to detect danger. Standing upright, even briefly, would have helped in scanning the surroundings, and alarm calls or gestures may have warned others of approaching threats. Movement across the landscape was probably cautious and deliberate. Open ground offered fewer hiding places, so travelling between tree clusters or along riverbanks may have been done with care, pausing frequently to observe and listen. Water sources were essential, not only for drinking but also because they attracted other animals and supported vegetation. Lakeshores and riversides would have been rich environments, providing opportunities to find food but also increasing the risk of encountering predators. One of the most intriguing aspects of Australopithecine life is what we do not see. There is little clear evidence of systematic tool use among most species of this group, although some stone tools dating to the later Pliocene suggest that simple toolmaking may have begun toward the end of their time. Even without formal tools, however, it is likely that they used natural objects in simple ways: sticks to probe, stones to crack, branches to reach. Such behaviours, common among modern apes, rarely leave traces in the fossil record, but they can play important roles in daily life. Communication within groups was probably complex, though not in the way humans use language. Vocalizations, facial expressions, and gestures would have conveyed information about food, danger, and social relationships. Emotional bonds, conflicts, and alliances were almost certainly part of their social world. Brains were still relatively small, but brain size alone does not determine behaviour. Even modest increases in cognitive ability can have significant effects on problem-solving, memory, and social interaction. Another feature that becomes clearer when studying Australopithecines is sexual dimorphism, the difference in size between males and females. In some species, males appear to have been significantly larger than females, which may indicate social structures involving competition for mates or hierarchical group dynamics. These social patterns, however, are difficult to reconstruct with certainty. Fossils provide bones and teeth, but behaviour must be inferred carefully, always with the understanding that ancient species may not have behaved exactly like any modern animal. One of the remarkable things about Australopithecines is how long they persisted. Some species existed for hundreds of thousands, even over 1 million years, adapting gradually as environments shifted. They were not a brief experiment, but a successful group, well suited to the conditions of their time. And yet, they were not the final step. Over time, some populations began to show changes that would eventually lead to the earliest members of the genus Homo. Brain size increased slightly. Teeth and jaws began to change. Tool use became more consistent. These developments did not happen everywhere at once. Different populations followed different paths, some continuing as Australopithecines for long periods, others gradually diverging. It is worth pausing to reflect on how quiet this transformation was. There was no clear boundary between ape and human, no moment when one species vanished and another suddenly appeared. There was only a gradual shift, generation by generation, shaped by countless small pressures: climate, geography, diet, social interaction. If you could stand on a hillside in East Africa 3 million years ago and watch a group of Australopithecines moving across the landscape, you might not recognize them as part of your own story. They would seem small, cautious, absorbed in the immediate tasks of survival. And yet, in their upright steps, in their flexible diets, in their social bonds, the foundations of later human evolution were already present. The world around them remained full of challenges. Food was not always plentiful. Predators were never far away. Seasons changed, landscapes shifted, and survival depended on constant awareness. Understanding these pressures helps explain why certain traits became more important over time, and why life on the ground, with all its dangers and opportunities, began to shape the course of revolution more strongly than ever before. At some point in the long, gradual unfolding of the Pliocene, spending time on the ground stopped being an occasional necessity and became an ordinary part of daily life for certain hominins. Trees were still important, still used for shelter, rest, and food, but the open spaces between them were no longer merely barriers to cross quickly. They became places where life happened, places where food was found, where groups moved, where survival played out in new and unfamiliar ways. Living on the ground changed almost everything. In the canopy, danger could come from above or below, but branches provided escape routes in many directions. On the ground, escape required speed, awareness, or cooperation. The horizon was wider, the cover less certain, and predators could approach from farther away. The Pliocene landscape was not empty. Large carnivores moved through grasslands and woodlands with practiced ease. Saber-toothed cats, early lions, hyenas, and other hunters occupied the same territories as early hominins. These predators were faster, stronger, and equipped with teeth and claws designed for killing. A small, upright primate would not have seemed intimidating prey. So how did early hominins survive? one important factor was vigilance. Groups could watch in multiple directions, detecting movement at a distance. Standing upright made this easier. Even brief pauses to scan the surroundings could reveal subtle signs. A shifting patch of grass, the silhouette of an animal against the sky, the sudden silence of birds that had been calling moments before. Awareness is one of the most powerful survival tools any species can possess, and early hominins were likely highly attentive to their environment, constantly listening, watching, and interpreting signals. Another factor was cooperation. A lone individual is vulnerable, but a group has many eyes, many ears, and the ability to respond collectively. Alarm calls, gestures, and movements could warn others of danger. Infants and juveniles could be protected within the group. Injured individuals might survive with assistance that would not be possible alone. Social bonds, already important in tree-dwelling ancestors, may have become even more critical in open environments. But life on the ground was not only about avoiding predators. It also opened new opportunities. Food sources that were difficult or impossible to access in trees became available. Tubers, roots, and other underground plant parts could be dug from the soil. Seeds and nuts scattered on the ground could be gathered. Insects, small animals, and carrion offered occasional protein. The ability to carry food, made easier by upright walking, meant that individuals could transport resources back to safer locations or share them within the group. This simple change, being able to move food from one place to another, has far-reaching consequences for social behaviour and survival strategies. Travel distances also changed. In forests, movement is often constrained by the distribution of trees and the difficulty of navigating dense vegetation. On the ground, especially in more open habitats, it becomes possible to travel farther in a day, exploring wider territories. Early hominins may have followed seasonal patterns, moving between areas as food availability shifted. Water sources, fruiting trees, and patches of edible vegetation would have formed a mental map of the landscape, guiding daily and seasonal movements. Memory, in this context, becomes essential. Knowing where to find water during the dry season, or where certain plants grow at particular times of year, can mean the difference between survival and starvation. There were also physical challenges associated with ground living. The sun in open environments can be intense, and shade may be limited. Walking long distances requires endurance. Feet must withstand repeated impact, and joints must support the body's weight in new ways. Over time, natural selection favoured anatomical features that made these tasks easier. The arch of the foot, the alignment of the knees, the structure of the pelvis, all contributed to more efficient walking. Even subtle changes in sweat glands and body hair distribution, which would become more pronounced later in human evolution, may have begun to play a role in regulating body temperature. Another difference between life in trees and life on the ground is exposure to the elements. Rain, wind, and temperature fluctuations are felt more directly. Shelter becomes something that must be sought out rather than simply climbed into. Early hominins likely used natural shelters, overhanging rocks, dense thickets, or tree clusters, to protect themselves from weather and predators. Night in particular would have been a time of heightened caution. Darkness reduces visibility, and many predators are most active after sunset. Climbing into trees to sleep may have remained common, offering safety above ground. But even this behaviour required careful selection of sleeping sites, balancing the need for security with proximity to food and water. One of the quieter but significant changes associated with ground living was the development of endurance. While early hominins were not built for sprinting, they may have been capable of walking steadily for long periods. This ability allows a group to cover large areas, locate scattered resources, and avoid competition by moving to less crowded regions. Endurance also changes how animals interact with their environment. Rather than relying on speed or strength alone, survival can depend on persistence, patience, and planning. There is another aspect of ground life that often goes unnoticed: the sensory experience of the world changes. On the ground, smells from plants, animals and soil are stronger and more varied. Sounds travel differently. The feel of the earth underfoot provides information about terrain, moisture, and obstacles. These sensory inputs form a constant stream of information, shaping behavior and awareness. It is likely that early hominins developed keen observational skills, noticing patterns in animal behavior, weather, and vegetation. Such awareness would later become a foundation for more complex forms of knowledge, but even at this early stage, it would have been vital for daily survival. Predators were not the only dangers. Injuries from falls, infections, and illnesses posed serious risks in a world without medicine. A broken bone or deep wound could be fatal. The survival of injured individuals may have depended on the care and tolerance of others in the group, reinforcing the importance of social bonds. Opportunities, however, continued to expand. Open landscapes provided access to new ecological niches. Some hominins may have scavenged carcasses left by predators, obtaining meat and marrow that offered high nutritional value. Even occasional access to such resources could influence diet, energy levels, and brain development over long periods. The use of simple tools, though still limited at this stage, may have begun to appear more frequently in ground-dwelling populations. Stones used to crack nuts or break bones, sticks used to probe or dig. These behaviours require hands free from locomotion and environments where suitable materials are available. Hands, once primarily tools for climbing, were gradually becoming tools for interacting with the broader environment. Another subtle but important change involved group movement. On the ground, groups must coordinate more closely, maintaining awareness of one another's positions, responding to signals, and adjusting pace. Communication becomes essential, not only for warning of danger, but for maintaining cohesion. Vocalizations, gestures, and expressions likely played an increasingly important role in coordinating movement and activity. Living in open habitats also meant encountering a greater variety of other animals. Herds of grazers moved across plains, birds nested in grasses, insects swarmed in seasonal patterns. Observing these animals could provide clues about the environment, where water might be found, where predators might be lurking when certain plants were in season. In this way, early hominins were not only adapting to their environment, but learning from it, building a form of ecological knowledge passed from one generation to the next. It is worth remembering that all of these changes occurred gradually. There was no clear moment when a population of tree-dwelling apes suddenly became ground-dwelling hominins. Instead, there was a long period of overlap, with individuals moving between trees and ground, adjusting behaviour in response to conditions. This flexibility was perhaps their greatest strength. Life on the ground demanded new skills, new awareness, and new social strategies. It also opened pathways that would eventually lead to further changes in diet, technology, and cognition. The Australopithecines, whom we have just met, were among the first to navigate this world successfully. They were not yet human, not yet tool makers in the full sense, but they were no longer confined to the trees. They were creatures of the woodland and savannah, shaped by the challenges and opportunities of a life at ground level. Every living creature spends a large part of its life solving one simple problem: finding enough food to survive. It sounds almost too ordinary to matter, but over long stretches of time, diet becomes one of the most powerful forces shaping evolution. What an animal eats influences the size and shape of its teeth, the strength of its jaws, the structure of its digestive system, and even the way it moves across the landscape. For the early hominins of the Pliocene, food was never guaranteed. The environments they lived in were changing. Seasons brought periods of abundance and scarcity, and competition with other animals meant that resources were not always easy to obtain. Survival depended not on specializing too narrowly, but on being flexible, able to eat a wide range of foods when conditions demanded it. One of the most informative clues about the diets of these early walkers comes from their teeth. Teeth preserve well in the fossil record, often surviving long after other bones have eroded away, and their shapes reveal a great deal about how they were used. Australopithecines, in particular, had large molars and premolars with thick enamel. These teeth were well suited for grinding and crushing tough foods, fibrous plants, seeds, roots, and possibly hard nuts. Thick enamel helps protect teeth from wear, especially when chewing abrasive materials that may contain tiny particles of grit or silica. The front teeth, or incisors, were relatively smaller than those of many apes that rely heavily on fruit. This suggests that while fruit was likely still part of the diet, these hominins were not exclusively fruit eaters. They needed to process foods that required powerful chewing rather than slicing or tearing. Jaws, too, tell part of the story. Some Australopithecines had robust jaw bones and large attachment areas for chewing muscles, indicating strong biting forces. Chewing tough plant materials requires sustained pressure, and individuals capable of processing such foods would have been better able to survive during periods when softer, more desirable foods were scarce. But teeth do more than reveal what animals could eat. Microscopic wear patterns on tooth surfaces provide clues about what they actually ate in the days or weeks before death. Scientists examine these patterns using magnification, looking for scratches and pits that indicate whether an individual consumed harder or softer foods. These studies suggest that many early hominins had varied diets, shifting between different food sources depending on availability. This flexibility would have been a major advantage in environments where rainfall and vegetation changed from season to season. Roots and tubers may have played an important role. Underground storage organs of plants can provide reliable nutrition, even during dry periods when leaves and fruits are scarce. Digging for such foods requires effort, but it offers a steady source of carbohydrates and other nutrients. Insects were likely another important food source. Termites, ants, and other insects are rich in protein and can be collected in large numbers. Even today, many primates consume insects regularly, using sticks or simply their hands to extract them from nests or logs. Occasional meat consumption may also have occurred. While early hominins were not active hunters in the way later humans became, they may have scavenged carcasses left behind by predators. Bones broken open with stones can yield marrow, a high-energy food that would have been valuable in times of scarcity. Such opportunities would not have been frequent, but even occasional access to nutrient-rich foods can influence survival and reproduction over long periods. Diet does not only shape teeth and jaws, it also influences behaviour. Finding scattered or seasonal foods requires movement across the landscape, memory of locations, and sometimes cooperation within groups. Sharing food, even in small amounts, can strengthen social bonds and improve the survival of offspring. It is interesting to consider how different foods require different skills. Gathering fruits from trees involves climbing and careful selection. Digging for roots requires knowledge of where edible plants grow and how to extract them. Scavenging from carcasses demands caution, as predators may still be nearby. Each activity shapes behaviour, and behaviour in turn can shape anatomy over generations. One of the challenges of plant-based diets is that many plants contain tough fibres or chemical defences that make them difficult to digest. Large molars and powerful jaws help break down these materials, but digestion also depends on gut structure and the time food spends in the digestive system. While we cannot directly observe the digestive systems of extinct species, comparisons with modern primates suggest that early hominins may have relied on a combination of easily digested foods and tougher fallback foods consumed when preferred items were scarce. Fallback foods are particularly important in evolutionary terms. A species may prefer soft fruits or tender leaves, but when those foods disappear during dry seasons, the ability to survive on tougher resources becomes critical. Teeth and jaws often reflect these fallback foods rather than the most frequently eaten items, because survival during hard times determines which individuals leave descendants. This principle helps explain why some Australopithecines developed such robust chewing adaptations. It was not necessarily that they preferred hard foods, but that they needed to be capable of processing them when other options were unavailable. Another way scientists study ancient diets is through stable isotope analysis. By examining the chemical composition of fossil teeth, researchers can infer the types of plants consumed, particularly whether they came from forests or grasslands. Different plants use different photosynthetic pathways, leaving distinct isotopic signatures that persist in tooth enamel. These studies have shown that some Australopithecines consumed significant amounts of grasses or animals that fed on grasses, indicating that their diets included resources from open habitats as well as wooded areas. This evidence reinforces the idea that early hominins were ecological generalists, able to exploit a wide range of environments rather than relying on a single type of habitat. Diet also influences life history. Foods that are difficult to chew or digest may require longer feeding times, shaping daily activity patterns. Energy-rich foods, on the other hand, can support larger brains or more energetically demanding behaviours, though the dramatic increase in brain size would come later in human evolution. For now, in the Pliocene, brains remained relatively small, and survival depended more on adaptability than on complex technology. There is another aspect of diet that often goes unnoticed: the role of taste and preference. Even animals without language or culture have preferences, choosing certain foods when available and avoiding others. These preferences can influence foraging patterns, movement across landscapes, and even social interactions within groups. Learning also plays a role. Young individuals must learn which plants are edible, where to find them, and how to process them. Mistakes can be dangerous, as some plants contain toxins or are difficult to digest. Knowledge passed from older to younger group members becomes a form of cultural inheritance, even in species without formal language. In this way, diet connects biology, behaviour and learning in subtle but powerful ways. Water too is part of the story of food and survival. Many plants provide moisture, but reliable water sources remain essential, especially in warm climates. Early hominins likely structured their movements around rivers, lakes, and seasonal streams, returning to familiar locations where water could be found. These places often supported richer vegetation and attracted other animals, creating zones of increased activity and competition. The search for food is rarely solitary in social species. Groups move together, spreading out to forage, then regrouping. Vocal calls or gestures help maintain contact, and the success of one individual in finding food can benefit others. Over long periods, such interactions may have encouraged greater tolerance and cooperation, traits that would become increasingly important later in human evolution. One might wonder how much time early hominins spent eating. Modern primates often devote several hours each day to feeding, especially when consuming fibrous plant materials that require prolonged chewing. Australopithecines likely followed similar patterns, alternating periods of feeding with rest, grooming and movement. The rhythm of their days would have been shaped by hunger, heat, and the availability of food rather than by clocks or schedules. It is worth pausing to reflect on how fundamental food is to the story of life. Every adaptation, every behaviour, every migration ultimately connects back to the need for energy. The shape of a tooth, the length of a limb, the structure of a social group, all can be traced in part to the demands of finding and processing nourishment. For early hominins, diet was not a matter of preference but of survival. The ability to eat a wide range of foods allowed them to endure in environments that were changing, sometimes gradually, sometimes unpredictably. And those changing environments did more than influence diet. They also shaped the course of evolution itself, creating periods of stability interrupted by shifts in climate and habitat that challenge populations to adapt or disappear. When we picture human evolution, it is tempting to imagine that everything began with a sudden expansion of the brain, as if intelligence appeared first and everything else followed. But the story is quieter than that. During the Pliocene, the brains of early hominins were still small, not dramatically larger than those of modern chimpanzees. And yet, something was already shifting, not in sheer brain size, but in how those brains were used, how behaviour adapted to changing environments, and how small cognitive advantages gradually accumulated across generations. To understand this, it helps to begin with a simple idea. Intelligence is not a single trait that appears all at once. It is a collection of abilities, memory, attention, problem-solving, communication, learning from others, each of which can change slowly over time. Even modest improvements in these areas can have significant effects on survival, especially in complex and changing environments like those of the Pliocene. Early hominins did not need to invent language or build elaborate tools to benefit from cognitive changes. They needed to remember where food could be found, recognize the signs of approaching danger, interpret social cues within their groups, and adjust their behaviour as conditions changed. These may seem like ordinary tasks, but they require flexible minds and careful attention. One of the most important mental abilities for any animal living in a patchwork landscape is spatial memory. When resources are scattered and seasonal, it becomes essential to remember locations over long periods of time. A grove of fruiting trees may be productive only for a few weeks each year. A water source may dry up during part of the dry season, but return with the rains. Knowing when and where to travel could mean the difference between hunger and survival. Modern primates demonstrate remarkable spatial awareness, sometimes remembering the locations of hundreds of food sources across large territories. It is reasonable to think that Australopithecines and other early hominins possessed similar abilities, navigating landscapes that required planning beyond the immediate moment. Planning, even in a simple form, represents an important step in cognitive evolution. It does not require complex language or abstract reasoning. It can be as straightforward as anticipating where food will be tomorrow, or choosing a safer route across open ground based on past experience. Memory also plays a role in recognizing individuals within a group. Social living depends on knowing who is trustworthy, who is dominant, who is related, and how to respond to each member of the community. These relationships form intricate networks, and maintaining them requires attention and learning. Grooming, for example, is not merely a hygienic activity in primates. It is a social behaviour that strengthens bonds, reduces tension, and reinforces alliances. Remembering past interactions, who groomed whom, who shared food, who gave warnings of danger, helps maintain group cohesion. These subtle social dynamics may have been becoming more complex during the Pliocene, even though the fossil record cannot directly reveal them. Larger groups, more varied environments, and increased reliance on cooperation could all have favoured individuals with slightly better social awareness. Another area where minds may have been changing is in the use of objects. Even before the first clear evidence of stone tool production appears, it is likely that early hominins were interacting with their environment in increasingly flexible ways. Picking up stones to crack nuts, using sticks to probe for insects, or selecting branches for specific purposes does not require advanced technology, but it does require curiosity and experimentation. Curiosity itself is an important cognitive trait. Individuals willing to explore new foods, new locations, or new methods of obtaining resources may discover opportunities that others overlook. Of course, curiosity also carries risks, especially when dealing with unfamiliar plants or animals, so it must be balanced with caution. Learning from observation is another powerful ability. Young individuals watch adults copying behaviours that prove successful. Over time, this process allows knowledge to accumulate within groups even in the absence of language. Certain techniques or foraging strategies may become traditions, passed down through generations. This form of cultural transmission, simple as it may be, represents a significant step toward the more complex cultures of later humans. It is also worth considering how changes in diet may have influenced the brain. While the dramatic increase in brain size would come later, even small shifts in access to higher quality foods, such as occasional meat or nutrient-rich plant sources, could support incremental changes in brain function. Brains are energetically expensive organs. Maintaining and developing them requires a steady supply of calories and nutrients. Any improvement in diet that increases available energy can create opportunities for subtle cognitive advantages to emerge. At the same time, brains do not evolve in isolation. They are shaped by the demands of the environment. A species living in a stable, unchanging habitat may have little need for innovation or flexible behavior. But in the Pliocene, environments were shifting. Forests expanded and contracted. Rainfall patterns varied. Food sources changed with the seasons. Under such conditions, individuals capable of adjusting their behavior quickly would have an advantage. Over many generations, these advantages can influence the evolution of the brain, even if the changes are gradual and difficult to detect in fossils. Another factor to consider is the development of attention. In open landscapes, vigilance is essential. Detecting predators at a distance, noticing subtle changes in the behavior of other animals, and responding quickly to threats require sustained focus. Attention is not merely a sensory process. It involves selecting relevant information from a constant stream of sights, sounds, and smells. Early hominins living on the ground would have needed to filter this information efficiently, prioritizing signals that indicated danger or opportunity. This heightened awareness may have shaped neural pathways related to perception and decision-making, gradually refining cognitive abilities over time. Communication also plays a role in shaping minds. While early hominins did not possess language as we know it, they almost certainly used a range of vocalizations, gestures, and facial expressions to convey information. Alarm calls, for example, must be understood quickly and acted upon immediately. Signals indicating food or social intentions require interpretation and memory. Over time, communication systems can become more nuanced, allowing groups to coordinate movements, share information, and maintain social bonds more effectively. It is interesting to reflect on how small improvements in communication can have large effects. A clearer warning call might allow a group to escape danger more quickly. A gesture indicating the location of food could reduce the time spent searching. These small efficiencies accumulate, shaping survival and reproduction. Sleep, too, may have played a role in cognitive development. Rest is essential for memory consolidation and brain function. Early hominins likely slept in trees or sheltered locations, maintaining patterns of rest that allowed their brains to process the experiences of the day. Dreams, though impossible to study in extinct species, are common in modern mammals and may have existed in early hominins as well. The brain, even in sleep, remains active, reinforcing memories and organizing information in ways that support learning. Another aspect of mental life that may have been changing is emotional complexity. Social animals experience a range of emotions: fear, curiosity, attachment, frustration, and perhaps forms of empathy. These emotional responses influence behavior, guiding decisions in ways that are not purely instinctive. For example, an individual that responds to the distress of another may help maintain group cohesion, indirectly benefiting its own survival. Emotional bonds between parents and offspring encourage prolonged care, increasing the chances that young individuals survive to adulthood. These emotional and social processes are rooted in the brain, and even small changes in neural organization can influence how individuals interact with one another. It is also important to remember that brain size alone does not determine intelligence. The organization of neural circuits, the density of connections, and the efficiency of information processing all matter. Early hominins may have been refining these aspects of brain function long before significant increases in overall brain volume occurred. The fossil record shows that Australopithecines had brains roughly the size of those of modern chimpanzees, yet their behavior and environments were different. Living in more open habitats, traveling longer distances, and adapting to variable climates likely placed new demands on their cognitive abilities. There is something quietly fascinating about this stage of evolution. It represents a period when behaviour was changing faster than anatomy. Minds were becoming more flexible, more attentive, more capable of learning and adapting, even while brain size remained relatively modest. Over time, these behavioural changes would create new selective pressures. Individuals capable of more complex problem-solving or social coordination might gain advantages, and gradually brain size would begin to increase in certain lineages. But in the Pliocene, the transformation was still in its early stages. Imagine for a moment a group of Australopithecines moving through a woodland at the edge of a grassland. One individual notices movement in the distance and pauses, standing upright. Others follow the gaze, scanning the horizon. After a moment, the group changes direction, avoiding a potential threat. No words are spoken, no elaborate plans are formed, and yet the group has made a collective decision based on observation, memory, and communication. Such moments, repeated countless times over generations, shape the course of evolution in ways that are easy to overlook but profoundly important. The world these early hominins inhabited was not static. Climate fluctuations, shifting landscapes, and changing food sources continued to present new challenges. Minds capable of adapting to these changes were among the most valuable tools any individual could possess. And while brains were still small, the foundations of later cognitive developments were already being laid. Foundations built from attention, memory, social learning, and the quiet, persistent ability to adjust to a world that never stood still. Life in the Pliocene was rarely solitary. For early hominins, survival depended not only on physical abilities or access to food, but on relationships, quiet, persistent bonds that shaped how individuals moved, fed, rested, and raised their young. Long before the appearance of villages or organised societies, the foundations of social life were already present in small groups, scattered across the landscapes of Africa. To understand these groups, it helps to begin with a simple observation. Primates, almost without exception, are social animals. Living in groups offers advantages that solitary life rarely provides. There is safety in numbers, shared vigilance against predators, and the possibility of cooperation in finding food or caring for offspring. These advantages existed for the ancestors of early hominins, and they became even more important as life on the ground exposed individuals to new dangers. A typical group of Australopithecines may have included several adults, juveniles of different ages, and infants carried by their mothers. The size of these groups is difficult to determine from fossils alone, but comparisons with modern primates suggest that they were probably small to moderate in size, perhaps ranging from a handful of individuals to a few dozen. Within such groups, relationships would have been complex, shaped by kinship, age, and experience. Mothers formed close bonds with their young, bonds that could last for years, as primate offspring require long periods of care and learning. Young individuals depended on adults not only for food and protection, but also for knowledge. What plants were safe to eat, where water could be found, how to recognize danger. Learning in this way is gradual. Juveniles watch, imitate, and practice. They experiment, sometimes making mistakes, sometimes discovering new ways to interact with their environment. Play, often seen in modern primates, is more than recreation. It helps develop coordination, social skills, and problem-solving abilities that will be essential in adulthood. Grooming was likely one of the most important social activities in these groups. While grooming removes parasites and keeps fur clean, its deeper function is social. It reinforces bonds, reduces tension, and establishes trust. Individuals that groom one another are more likely to cooperate, defend each other, or share resources when needed. This kind of bonding creates networks of relationships that hold groups together, even in the face of challenges. Conflicts still occur, of course. Competition for food, mates, or status can lead to disputes, but social mechanisms, Reconciliation behaviours, alliances, and subtle negotiations help maintain stability. Communication played a central role in these interactions. Early hominins did not possess language in the modern sense, but they almost certainly used a rich system of vocalizations, gestures, and facial expressions. A raised arm, a particular call, or a shift in posture could convey meaning understood by others in the group. Alarm calls, for example, would have been essential. Different sounds might signal different types of threats, prompting appropriate responses. A distant predator requires vigilance, while an immediate danger demands swift retreat or climbing. Over time, the ability to interpret and respond to such signals becomes finely tuned, shaping both perception and social awareness. Another important aspect of social life is the division of attention and roles within a group, not in the structured way seen in later human societies, but in subtle, flexible ways. Some individuals may have been more attentive to distant movement, others more skilled at locating food, others particularly adept at caring for young. These variations in behaviour contribute to the resilience of a group. Diversity of skills and temperaments allows groups to respond to a wider range of situations. Infants and juveniles, being the most vulnerable members, likely occupied the centre of group movements, surrounded by adults who could respond quickly to threats. Mothers carried their infants for long periods, and older siblings or other adults may have assisted in watching over younger individuals, a behaviour seen in many modern primates. This shared attention to offspring represents an early form of cooperative care, a pattern that would become increasingly important in later stages of human evolution. One of the most significant consequences of social living is the need for memory, not only of places and resources, but of individuals and interactions. Remembering who shared food, who offered protection, or who posed a threat helps guide future behaviour. Such social memory requires cognitive capacity and attention, reinforcing the gradual changes in mental abilities we explored earlier. It is also likely that early hominins experienced emotional lives richer than we sometimes assume. Fear, curiosity, attachment, and perhaps even forms of empathy would have influenced their behaviour. A distressed infant's cries prompt immediate responses in modern primates, and similar reactions almost certainly occurred in Pliocene groups. Emotions, in this sense, are not abstract qualities, but practical tools shaped by evolution to support survival and cooperation. Group movement across the landscape required coordination. Individuals needed to remain within sight or sound of one another, adjusting pace and direction as needed. Vocal calls helped maintain contact when vegetation obscured visibility, and visual signals guided movement in more open areas. These daily movements, repeated over years and generations, created shared knowledge of territories, where to find water, where certain plants grew, where predators were often encountered. Such shared knowledge forms the beginnings of what we might call culture, even if it is simple and unwritten. Information passed from one generation to the next through observation, and imitation becomes part of a group's way of life. Another feature of social life is the establishment of hierarchies or dominance relationships. In many primate species, individuals compete for status, which can influence access to food or mating opportunities. While the exact structure of early hominin societies is unknown, some degree of hierarchy likely existed, shaped by physical strength, alliances, and experience. Yet hierarchy does not mean constant conflict. Most of daily life would have been peaceful, focused on feeding, resting, grooming, and caring for young. Dramatic confrontations, while memorable, are usually rare compared to the quiet routines that occupy most hours. Night brought its own patterns of social behaviour. Groups likely settled in safe locations, perhaps climbing trees or choosing sheltered areas. Infants stayed close to their mothers. Adults remained alert to unfamiliar sounds, and the darkness was filled with the calls of nocturnal animals. Sleep, though necessary, required trust in the group and in the chosen resting place. Safety during the night depended on the vigilance and cooperation of others. it is worth reflecting on how deeply social living shaped the course of evolution. Individuals who cooperated effectively, who maintained bonds, and who contributed to group survival were more likely to raise offspring successfully. Over time, these social traits became more pronounced, reinforcing behaviours that favoured cohesion and communication. This process did not require conscious intention. It unfolded gradually, generation by generation, as small advantages in social behaviour translated into greater survival. The landscapes of the Pliocene, with their scattered resources and persistent dangers, encouraged this reliance on one another. A group moving together could travel farther, detect threats earlier, and share knowledge more effectively than any individual alone. There is something quietly moving about imagining these small groups, walking through grasslands and woodlands, communicating in ways we can only partly reconstruct, caring for their young, learning from one another, living lives that were at once ordinary and part of a vast evolutionary story. Their world was not easy, but it was rich in relationships, shaped by bonds that allowed them to endure in changing environments. The world of the Pliocene was not a place of steady, unchanging conditions. Temperatures shifted, rainfall patterns rose and fell, lakes expanded and vanished, forests spread, and then retreated again. These changes did not happen overnight, but they were persistent, repeating over long cycles that shaped the lives of every creature living on the landscape. To understand why this mattered so much, it helps to think of evolution not as a smooth, constant process, but as something that often accelerates during periods of change. When environments remain stable for very long stretches of time, species can become highly specialized, finely tuned to particular foods, habitats, and conditions. But when environments begin to fluctuate, specialization can become a disadvantage. Flexibility, instead, becomes the key to survival. The Pliocene was a time of these fluctuations, sometimes called climate pulses. These were long-term cycles in which conditions alternated between wetter and drier, warmer and cooler, sometimes gradually, sometimes more abruptly. Each pulse reshaped landscapes, altering vegetation, water availability, and the distribution of animals. In East Africa, where many early hominins lived, evidence from lake sediments, fossil pollen, and isotopic studies reveals repeated expansions and contractions of forests and grasslands. During wetter periods, lakes filled and woodlands spread. During drier intervals, lakes shrank or disappeared, and open grasslands became more extensive. For animals living in these regions, such changes required constant adjustment. Food sources that were reliable in one generation might become scarce in the next. Migration routes shifted. Predators and competitors moved into new areas. For early hominins, these pulses of environmental change may have been among the most important forces shaping evolution. One reason instability can drive evolution is that it creates repeated challenges. A population that survives one period of drought may do so because some individuals happen to possess traits that allow them to cope better with scarcity. Perhaps the ability to eat tougher foods, travel longer distances, or tolerate heat more effectively. When conditions change again, different traits may become advantageous. Over many cycles, populations accumulate a broader range of adaptations, becoming more flexible and resilient. This idea is sometimes called the variability selection hypothesis. It suggests that the key factor in human evolution was not simply living in open grasslands or forests, but living in environments that changed repeatedly. Under such conditions, the ability to adapt quickly, to learn, and to exploit diverse resources becomes more valuable than being perfectly suited to any single habitat. The fossil record provides some support for this view. Periods of increased environmental variability often coincide with bursts of evolutionary change, including the appearance of new species or the disappearance of others. It is important to remember that these changes unfolded over thousands or tens of thousands of years, far longer than any individual lifetime. Early hominins did not experience climate pulses as dramatic events, but as gradual shifts that altered the world they knew. A lake that was full during childhood might be smaller in adulthood. A woodland that once provided fruit might thin over decades, replaced by grasses and shrubs. Seasonal rains might become less predictable, forcing groups to travel farther in search of water. These gradual changes influenced behaviour first. Groups adjusted their movements, diets, and social strategies in response to new conditions. Over many generations, these behavioural shifts created selective pressures that shaped anatomy and physiology. For example, if resources became more widely scattered, individuals capable of travelling longer distances efficiently would have an advantage. If drought reduced the availability of soft fruits, individuals able to process tougher foods would be more likely to survive. In this way, climate pulses acted as a kind of slow, persistent filter, shaping populations in subtle but powerful ways. Another consequence of environmental variability is the fragmentation of habitats. As forests contracted, populations that once lived in continuous woodland might become isolated in separate patches. Isolation can lead to genetic divergence, as groups adapt to slightly different conditions and accumulate distinct traits over time. Later, when conditions change again and habitats reconnect, these populations may encounter one another as different species or subspecies, adding to the diversity of life. This pattern of isolation and reconnection appears repeatedly in the fossil record and may have played an important role in the diversification of early hominins. Water availability was one of the most significant factors influenced by climate pulses. Lakes in the East African Rift Valley expanded dramatically during wetter periods, sometimes forming vast bodies of water. During drier intervals, many of these lakes shrank or disappeared, leaving behind salt flats or dry basins. For animals dependent on these water sources, such changes required migration or adaptation. Groups that could adjust their territories or exploit alternative resources were more likely to survive. The presence or absence of water also influenced vegetation. Grasses spread in drier conditions, while trees and shrubs expanded when rainfall increased. These shifts, in turn, affected herbivores and the predators that hunted them. Early hominins living in these landscapes were part of this chain of changes, responding to each new configuration of the environment. It is interesting to consider how repeated exposure to variability might shape not only physical traits, but also behaviour and cognition. A species living in an unpredictable environment benefits from learning, memory, and the ability to innovate. Individuals that can adjust their behaviour quickly are better able to cope with sudden changes. Over time, such pressures may have contributed to the gradual development of more flexible minds, laying the groundwork for later increases in brain size and complexity. There is also evidence that climate variability influenced the pace of evolution itself. Periods of environmental stress can lead to population bottlenecks, where only a small number of individuals survive. These bottlenecks reduce genetic diversity but can also accelerate the spread of advantageous traits within a population. When conditions improve, populations expand again, carrying those traits forward. This cycle of contraction and expansion, repeated over many generations, can produce noticeable evolutionary changes in relatively short geological periods. Of course, not all species survived these fluctuations. The fossil record is filled with examples of animals that thrived for hundreds of thousands of years and then disappeared when conditions changed beyond their ability to adapt. Extinction is a natural part of evolution, though it often feels tragic when viewed from a human perspective. For every lineage that continued, many others ended, leaving only fragments of bone and traces in sediment. Early hominins were not immune to this process. Several species that appeared during the Pliocene eventually vanished, replaced by others better suited to new conditions. Another important factor in climate pulses is the role of orbital cycles. Variations in Earth's orbit and tilt, known as Milankovitch cycles, influence the distribution of sunlight across the planet, affecting climate patterns over tens of thousands of years. These cycles contribute to the alternation of wetter and drier periods in regions like East Africa. Though invisible to the creatures living at the time, these astronomical rhythms quietly shape their world, altering rainfall and vegetation in ways that influence survival and evolution. It is humbling to think that the movements of the Earth around the Sun, slow and predictable, could shape the course of life on the ground in such profound ways. The concept of instability driving evolution may seem counterintuitive at first. We often think of stability as desirable, a condition in which life can flourish, and in many cases that is true. But from an evolutionary perspective, change creates opportunities. New environments open new niches, changing conditions favour new adaptations, populations that can adjust, survive and diversify, while those that cannot gradually disappear. For early hominins, the Pliocene was a time of such opportunities. Climate pulses reshaped landscapes repeatedly, encouraging flexibility in diet, movement and social behaviour. Traits that supported adaptability, upright walking, varied diets, social cooperation and cognitive flexibility became increasingly important. These changes did not happen all at once, nor did they follow a single inevitable path. Evolution is always a branching process, and many different hominin species experimented with different strategies, but the pattern of variability remained constant. A background rhythm influencing the course of life. If you imagine standing on a hillside overlooking a Pliocene valley, you might see a lake shimmering in the distance, herds of animals moving across grasslands, clusters of trees along riverbanks. Over decades, the lake might shrink, the grasses spread, and the animals change their routes. To the individuals living there, these changes would feel gradual, almost imperceptible. But over thousands of years they would transform the entire ecosystem. Long after early hominins had begun walking upright, long after they had adapted to life in shifting landscapes of woodland and grassland, another quiet change began to take shape. It did not arrive suddenly, and at first it would not have been obvious to anyone watching from a distance. There were no workshops, no carefully shaped implements in neat rows, no sense of invention as we understand it today. There were only stones, scattered across riverbanks and dry stream beds, and hands that were beginning, little by little, to use them in new ways. The earliest tools were not dramatic. They did not transform the world overnight. In fact, if you walked past one lying in the dust, you might not even notice it. A stone with a sharp edge, struck in such a way that flakes had been removed, leaving a surface capable of cutting or scraping. Simple, practical, unremarkable at first glance. And yet, these modest objects represent one of the most significant shifts in the history of our lineage. To understand why tools began to matter, it helps to think again about the lives of early hominins. Food was not always easy to obtain. Tough plant materials required processing. Bones left behind by predators contained marrow that was rich in energy, but difficult to access without breaking the bone. Tubers buried in the soil were nutritious but required effort to extract. Hands alone could accomplish much, but tools extended what hands could do. At first, the use of objects in the environment was likely opportunistic. A stone picked up to crack a nut, a branch used to dig or probe. Such behaviours are seen even in modern primates, and it is reasonable to think that early hominins behaved in similar ways long before the first deliberately shaped tools appeared. But there is a difference between using an object as found and shaping it intentionally. The earliest known stone tools, dating to around 3.3 million years ago in places like Lomekwi in Kenya, suggest that some hominins had begun to strike stones together deliberately, producing flakes with sharp edges. These tools are older than the earliest members of the genus Homo and may have been made by Australopithecines or closely related species. Imagine the moment such a behaviour first appeared. Perhaps an individual dropped a stone onto another stone and noticed the sharp edge that resulted. Perhaps curiosity led to repeating the action. A sharp flake proved useful for cutting plant fibres or scraping meat from bone. Over time, such actions could be repeated, refined, and passed on through observation. There was no blueprint, no teaching in the formal sense, only imitation and experimentation. This process is important because it represents a new way of interacting with the environment. Instead of relying solely on teeth and hands, early hominins were beginning to alter objects to suit their needs. Even simple tools can change behavior. A sharp edge allows meat to be cut more efficiently, reducing the time spent feeding in exposed locations. Breaking bones to extract marrow provides access to calories that would otherwise remain unavailable. Digging tools allow roots and tubers to be obtained more easily. Each of these small advantages can influence survival, especially during times of scarcity. It is also possible that tools played a role in social behavior. Food obtained through the use of tools might be carried back to others, encouraging sharing, or at least the presence of group members during feeding. Watching another individual use a tool could lead to imitation, spreading knowledge through the group. This form of learning, based on observation rather than instinct alone, represents an important step in cultural transmission. The earlier stone tools were simple, often consisting of a core from which flakes had been struck, and the flakes themselves. The process required selecting appropriate stones, ones that would fracture in predictable ways, and striking them with enough force at the right angle. Even this simple technique requires coordination, attention, and an understanding of cause and effect. The maker must anticipate how the stone will break, adjust grip and angle, and recognize when a useful edge has been produced. These are not trivial cognitive tasks. They do not require advanced language or abstract reasoning, but they do involve planning and fine motor control. Hands, already freed from locomotion by bipedalism, were now being used in increasingly versatile ways. The thumb, capable of opposing the fingers, allowed precise grips that made tool use more effective. Over time, natural selection may have favoured individuals with slightly greater dexterity or coordination, reinforcing these abilities. Another important aspect of early tool use is that it did not occur in isolation from the environment. Stone suitable for toolmaking is not evenly distributed across landscapes. Riverbeds, lake shores, and certain geological formations provide better materials than others. This means that early hominins may have travelled to particular locations to obtain stone, carrying pieces with them or returning repeatedly to the same places. Such behaviour suggests memory, planning, and a growing awareness of resources beyond immediate surroundings. It also suggests that certain places may have become focal points of activity, where tools were made and used over many generations. Evidence from archaeological sites often shows clusters of stone flakes and animal bones, indicating locations where early hominins processed food. These sites were not settlements in the modern sense, but temporary gathering points, used and reused as part of seasonal movements across the landscape. The appearance of tools also influenced diet. With the ability to cut and scrape, meat became easier to consume, even if obtained through scavenging rather than hunting. Marrow protected within bones could be accessed with stones, providing fats and nutrients valuable for energy. While meat was probably not yet a dominant part of the diet, even occasional consumption of high-energy foods can have long-term effects on physiology and behaviour. Time spent feeding may have decreased, freeing time for other activities, movement, social interaction, or rest. Over many generations, such changes can subtly reshape daily life. It is interesting to reflect on how quiet this transition must have been. There was no moment when a group suddenly became tool makers in the way later humans would be. There were only individuals experimenting, discovering and repeating behaviours that proved useful. Some individuals may never have used tools at all, relying on traditional foraging methods. Others may have adopted tool use more readily, passing the behaviour to their offspring or companions. Variation within populations is one of the driving forces of evolution, and tool use was likely no exception. Another subtle but important consequence of tool use is the change it brings to perception. Once an individual begins to see objects in the environment not only as they are but as what they might become, a stone that could be sharp, a branch that could be used for digging, the world itself begins to look different. potential uses become visible where none were noticed before. This shift in perception, though small at first, represents a profound step toward the technological minds of later humans. There is also the matter of patience. Making even a simple stone tool requires time and repeated strikes, and the results are not always predictable. Learning to persist through failed attempts, to adjust technique, and to recognize success requires a certain temperament, a willingness to experiment. Such behavioral traits, once advantageous, can become more common within populations over time. Of course, tools did not eliminate the dangers of life on the ground. Predators remained a constant threat. Injuries and illness still posed serious risks. Early hominins were still small, relatively slow creatures in a world filled with larger and more powerful animals. But tools added a new dimension to survival, extending the capabilities of hands and teeth, allowing resources to be used in ways that were previously impossible. It is also worth considering how tools may have influenced social dynamics. Individuals skilled in making or using tools might have gained status or influence within their groups. Observing such individuals could encourage others to learn, spreading techniques through imitation. Knowledge, even simple knowledge, becomes a resource in its own right. Over time, the archaeological record begins to show increasing sophistication in stone tools, especially in later periods. But in the Pliocene, the tools were still rudimentary, their makers still at the beginning of a long journey. What matters most is not their complexity, but their existence. The first tools mark the beginning of a relationship between hominins and the material world that would grow ever deeper. Stones were no longer just stones, they were possibilities. Imagine for a moment a small group gathered near a riverbank. One individual sits with two stones, striking one against the other, flakes scattering onto the ground. Others watch, curious, perhaps picking up flakes and testing their edges on plant stems or pieces of bark. There is no sense of ceremony, no awareness of history in the making, only practical activity carried out for immediate needs. And yet, from such ordinary moments, entire futures can unfold. The appearance of tools did not immediately transform hominins into something new, but it marked a turning point. It showed that behaviour could shape the environment, that objects could be modified to serve purposes beyond their natural forms. This capacity, once established, would continue to expand over millions of years, eventually leading to technologies far beyond anything those early tool users could have imagined. For now, however, the story remains grounded in the Pliocene world, a world of shifting climates, expanding grasslands, and small groups of early walkers navigating the challenges of life on the ground. No matter how adaptable early hominins became, no matter how well they learned to walk, to forage, or even to shape simple tools, the world they lived in was never safe. Every day unfolded along a narrow margin between survival and danger. Food had to be found, water located, shelter chosen carefully, and all of it done while sharing the landscape with animals that were faster, stronger, and in many cases perfectly equipped to kill. It is easy, from a modern perspective, to underestimate how dangerous the Pliocene world was for a small, upright primate. Today, most people move through environments where large predators are absent, where night brings quiet rather than prowling hunters, and where injury or illness can be treated. For early hominins, the situation was very different. Danger was not occasional. It was constant, a quiet presence at the edge of awareness, shaping behaviour in ways that became part of daily life. Among the most formidable predators were large cats. Some of them resembled lions or leopards, while others, like the saber-toothed cats, were specialised hunters with enormous canine teeth, designed to deliver powerful killing bites. These animals were ambush predators, relying on stealth, patience, and explosive bursts of speed. In tall grass or broken woodland, they could remain nearly invisible until the moment of attack. For a hominin group moving across open ground, this meant vigilance was essential. Individuals likely paused frequently to scan their surroundings, listening for unusual sounds, watching for subtle movements in vegetation, or observing the behaviour of birds and other animals, which often react quickly to the presence of predators. Alarm calls and gestures would have played a crucial role here. A sudden sound or signal could bring an entire group to alertness within seconds. Infants would be gathered, individuals would cluster together, and movement would shift towards safer terrain, perhaps toward trees or rocky outcrops where escape routes were more secure. Hyenas and other scavengers posed different kinds of threats. While not always hunters in the same sense as large cats, they were opportunistic and often bold, capable of challenging other animals for carcasses or attacking vulnerable individuals. Their powerful jaws allowed them to crush bone, leaving little behind once they had fed. Crocodiles lurking in rivers and lakes added another layer of danger. Water was essential, but approaching a riverbank required caution. Modern animals often drink in groups, with some individuals watching while others lower their heads to drink, and it is likely that early hominins adopted similar strategies. Even birds of prey could be a threat, particularly to infants. Large eagles are known to prey on small primates today, and there is fossil evidence suggesting that early hominins sometimes fell victim to aerial predators. Living under such conditions required more than physical adaptation. It required awareness, communication, and cooperation. A group that worked together could detect danger earlier, respond more effectively, and protect its most vulnerable members. Competition, however, was not limited to predators. Other herbivores and omnivores also competed for food and territory. Grazing animals consumed grasses that shaped the landscape. Other primates competed for fruits and leaves in woodland areas. Even smaller animals could influence resource availability by consuming seeds or roots that hominins might otherwise have eaten. Competition does not always involve direct conflict. Often, it takes the form of quiet displacement, one species gradually occupying habitats that another species once used, or feeding at times of day when others are absent. For early hominins, flexibility in diet and movement helped reduce direct competition. Being able to eat a wide range of foods meant they were not dependent on a single resource. Being able to move efficiently allowed them to explore new areas when familiar ones became crowded or depleted. Still, encounters with other animals must have been frequent. Herds of antelope and other grazers moved across the plains, sometimes in vast numbers. These animals, alert and quick, could serve as indicators of danger. A sudden stampede or change in behaviour might signal the presence of a predator, providing a warning to any attentive observer. In this way, early hominins were part of a complex web of interactions, constantly reading the signals provided by other species. There were also dangers that came not from animals but from the environment itself. Heat, dehydration, and exposure posed serious risks, especially in open habitats. A long journey without access to water could be fatal. Sudden storms could flood low-lying areas or make travel difficult. Injuries were particularly dangerous. Broken bone, a deep cut, or an infected wound could end a life, especially if the individual could no longer keep up with the group. The survival of injured individuals may have depended on the tolerance and assistance of others, reinforcing the importance of social bonds. It's worth considering how these constant pressures shape behaviour. Individuals who were attentive, cautious, and capable of learning from experience would have been more likely to survive. Groups that cooperated effectively would have had an advantage over those that did not. Over many generations, such behavioural tendencies can become more common, not because individuals consciously choose them, but because those who possess them are more likely to raise offspring successfully. Predators also influence the timing of activity. Early hominins were probably most active during daylight hours, when visibility was greatest and many predators were less active. Night brought different dangers, and finding safe places to rest became essential. Climbing into trees, choosing elevated ground, or sleeping in dense vegetation may have provided protection, though no location was completely safe. The sounds of the night, distant calls, rustling leaves, the movement of unseen animals would have been familiar companions. There is something striking about how much of life must have been shaped by anticipation. Listening for danger, watching the horizon, interpreting the behaviour of other animals, these actions require attention and memory, reinforcing the gradual cognitive changes we have already considered. Predation pressure may even have influenced physical traits. Standing upright, for example, makes it easier to detect predators at a distance. Group living reduces individual vulnerability. The ability to travel long distances allows escape from areas where predators are particularly abundant. These traits, once established, would continue to shape the course of evolution. Another aspect of competition involved access to carcasses. Large predators often left behind remains that could be scavenged, but these resources were contested by hyenas, vultures, and other scavengers. Approaching a carcass required caution, awareness, and sometimes timing, waiting until dominant scavengers had finished before moving in to extract what remained. Simple tools, as we've seen, could help in breaking bones or cutting meat, but using them near a carcass also meant exposure to danger. A hominin group scavenging in such a setting would have needed to remain alert, ready to retreat quickly if a predator returned. This balance between risk and reward shaped behaviour in subtle ways. High-energy foods like marrow or meat could provide valuable nutrition, but obtaining them required careful judgment. There is also the matter of territory. While early hominins likely did not defend territories in the rigid way some animals do, groups probably had home ranges, areas they knew well, where they understood the locations of water, food, and shelter. Encounters with other hominin groups may have occurred at the edges of these ranges. Such encounters could have been peaceful, involving observation and avoidance, or occasionally tense, especially if resources were scarce. The social dynamics of these encounters are difficult to reconstruct, but they remind us that early hominins were not only interacting with other species but also with members of their own kind, sometimes cooperating, sometimes competing. All of these pressures, predation, competition, environmental hazards, created a constant edge of survival. Life was not secure, and yet it persisted. It is easy to imagine this world as harsh and unforgiving, but it is also important to remember that it was rich in life. Herds grazed, birds nested, rivers flowed, and plants flowered in seasonal rhythms. Danger was part of the environment, but so was abundance, at least during certain times of year. Early hominins were not merely surviving, they were living, forming bonds, raising young, exploring landscapes, and gradually adapting to the conditions around them. If you picture a group moving at dawn, the air still cool, the grass silvered with dew, you can imagine how the day might unfold. They travel cautiously, stopping to forage, pausing to drink, resting in shade during the heat of midday, then moving again as the sun lowers. Throughout the day they remain aware of their surroundings, reading the landscape in ways that become second nature. Tracks in the soil, distant calls, the direction of the wind carrying unfamiliar scents. Such awareness, repeated day after day, shapes minds and bodies alike. Over many generations, these experiences accumulated, influencing the direction of evolution in ways that were subtle but persistent. Traits that supported cooperation, awareness, and adaptability became more important, gradually setting the stage for further changes. Across millions of years, there are certain places on Earth where change seems to gather, where geography, climate, and life interact in ways that quietly shape the future. During the Pliocene, one of those places was East Africa. It was not the only region where hominins lived, but it was a landscape where many of the forces we have been exploring, climate variability, shifting vegetation, evolving animals, and small populations of upright walking primates, came together in particularly powerful ways. To picture this region, it helps to imagine a vast corridor running north to south, marked by valleys, highlands, and lakes. This is the East African Rift System, a geological feature so large that it can be seen from space today. But in the Pliocene, it was not yet exactly as it appears now. The land was still slowly pulling apart, the crust thinning and cracking, volcanoes rising and eroding, lakes forming and vanishing as the landscape shifted. These geological processes unfolded at a pace far too slow for any individual to notice, but over thousands of years they reshaped entire ecosystems. Valleys deepened, ridges rose, drainage patterns changed, and new basins filled with water. Each of these changes influenced where plants could grow, where animals could travel, and where hominin groups could find food and shelter. One of the defining features of the Rift Valley was its diversity of habitats within relatively short distances. A group travelling only a few days might pass through open grassland, wooded slopes, marshy lake shores, and rocky highlands. Each of these environments offered different resources and different challenges. Lakes were particularly important. During wetter periods, some of these lakes expanded into large inland seas, supporting fish, birds, and lush vegetation along their shores. Reeds and grasses grew thick near the water's edge, and animals of many kinds came to drink. Such places would have been rich in opportunities for early hominins: water, edible plants, insects, and occasionally the remains of animals that had died nearby. Yet lakes were not permanent. Climate pulses caused them to rise and fall repeatedly. A shoreline that provided abundant food for one generation might retreat kilometres away within a few centuries, leaving behind dry ground and salt flats. Groups that depended too heavily on a single location would have struggled, while those capable of moving and adapting would have fared better. This pattern of expansion and contraction created a landscape that rewarded flexibility. It also encouraged movement, and movement has profound effects on evolution. Populations that move across varied terrain encounter new conditions, new food sources, and sometimes new dangers, all of which shape behaviour and, over time, anatomy. Volcanoes also played a role in shaping East Africa. Many of the highlands in the region were formed by volcanic activity, and eruptions periodically spread ash across wide areas. While destructive in the short term, volcanic ash often enriches soils, making them fertile once vegetation returns. Grasses and shrubs can grow quickly in such soils, attracting herbivores and in turn predators. In some cases, volcanic ash preserved remarkable traces of life. Footprints left in soft ash could harden and be buried, remaining intact for millions of years. These preserved tracks, like those found at Dietary, provide rare and intimate glimpses of early hominins walking across ancient ground, step by step, in a world long vanished. The geography of East Africa also influenced rainfall. Highlands forced moist air upward, causing precipitation on one side of a ridge while leaving the other side drier. These rain shadows created sharp contrasts in vegetation over relatively short distances, further increasing the diversity of habitats. For early hominins, this meant that options were often nearby. If one area became less productive, another might still offer resources. The ability to move between these areas, remembering routes and seasonal patterns, would have been a valuable skill. Rivers flowing through the Rift Valley formed natural corridors for movement. Animals often follow watercourses, and early hominins likely did the same, travelling along riverbanks where water, shade and food were more readily available. These corridors also connected different regions, allowing populations to spread and occasionally to meet other groups. At times, however, geographic features could isolate populations. A large lake, a steep escarpment, or a stretch of unsuitable habitat might separate groups for thousands of years. During such periods of isolation, populations could diverge, adapting to slightly different conditions and gradually becoming distinct species. Later, when climates shifted and barriers disappeared, these populations might encounter one another again, adding to the diversity of hominins living in the region. This pattern of separation and reconnection appears repeatedly in the fossil record and may help explain why East Africa contains such a rich variety of hominin fossils from the Pliocene and later periods. Another aspect of the landscape that influenced life was the distribution of vegetation. Grasslands expanded in some areas, while woodlands persisted in others. patches of forest remained along rivers and in higher elevations, providing refuge and food sources for animals adapted to those environments. Early hominins living in this mosaic landscape were not confined to a single habitat. They could move between open and wooded areas, exploiting different resources as conditions changed. This versatility, as we have seen, was one of their greatest strengths. The presence of large grazing animals also shaped the landscape. Herds of antelope, early zebras and other herbivores fed on grasses, influencing plant communities and creating pathways across plains. Predators followed these herds, and scavengers followed predators, forming a dynamic web of interactions in which early hominins were participants rather than observers. If you imagine standing on a ridge overlooking a Pliocene valley in East Africa, the view might be surprisingly familiar in some ways. The sky would stretch wide, clouds casting slow-moving shadows across the land. In the distance, a lake might glimmer, bordered by reeds and trees. Herds would move in loose formations across grasslands, and birds would circle overhead. Yet there would be differences as well. Some species would be unfamiliar, some plants unlike those seen today. And somewhere within that landscape, small groups of upright walking hominins would be moving carefully, watching, listening, and adapting to the world around them. The sounds of such a landscape would be constant but varied. Insect buzzing in the heat, the calls of birds, the distant lowing or snorting of grazing animals, the rustle of wind through grass. At night, different sounds would emerge, the cries of nocturnal predators, the movements of unseen creatures, the steady rhythm of the natural world continuing in darkness. Living in such a place requires not only physical adaptation, but a deep familiarity with the environment. Early hominins likely knew their surroundings intimately, recognizing landmarks, remembering seasonal changes, and interpreting subtle signs in the behavior of animals and the growth of plants. This knowledge, passed from one generation to the next, formed a kind of unwritten map of the landscape, guiding movements and decisions. The East African Rift was not the only region where early hominins lived, but it provided a unique combination of factors that encouraged evolutionary change. Geological activity created varied terrain. Climate variability produced shifting habitats. Diverse ecosystems offered a wide range of resources. Together, these conditions formed a setting in which adaptability was continually tested and rewarded. It is also worth reflecting on how time moved in such a landscape. For the individuals living there, life was immediate. Finding food, caring for young, avoiding danger. The slow changes of geology and climate would have been invisible within a single lifetime. Yet over thousands of generations, those slow changes reshaped the entire region, influencing the course of evolution in ways that would only become clear millions of years later. Fossils discovered in East Africa provide some of the most detailed records of early hominins, from Australopithecines to the earliest members of the genus Homo. These discoveries remind us that this region was not just a place where hominins happened to live. It was a place where key transitions unfolded, where bodies and behaviours changed in response to a landscape that was itself in motion. There is something quietly fitting about this. A landscape defined by rifting, by gradual separation and transformation, became the setting for a lineage that was also changing, slowly but persistently, moving toward forms that would eventually become recognisably human. By the later part of the Pliocene, something gradual but unmistakable was unfolding among certain populations of hominins. The Australopithecines, who had already spent hundreds of thousands of years adapting to life in mixed woodland and savanna environments, were not disappearing all at once, nor were they suddenly transforming into modern humans. Instead, small changes were accumulating. Changes in teeth, in proportions of the body, in behaviour, and eventually in the brain. Over long spans of time, these changes would give rise to the earliest members of the genus Homo, the group to which we belong. It is important to picture this transition as slow and uneven. Evolution rarely produces sharp boundaries. If you could walk through the landscapes of East Africa across a few 100,000 years, you would not see a clear dividing line where Australopithecines ended and humans began. You would see populations with slightly different features, some more robust, some more graceful, some with faces and teeth a little closer to later human forms, others retaining more ancestral characteristics. One of the first noticeable trends involved the teeth and jaws. Australopithecines often had large molars and strong jaws adapted for heavy chewing, especially of tough plant materials. In some later hominins, teeth began to become slightly smaller, and the structure of the jaw began to change. This did not mean that diets suddenly shifted to something entirely different, but it suggests gradual changes in how food was obtained and processed. The increasing use of tools likely played a role here. Even simple stone flakes can make it easier to cut plant fibers, scrape meat, or break open bones. When tools assist in food processing, the selective pressure for extremely powerful jaws and teeth can diminish slightly. Over many generations, this can lead to subtle anatomical changes. Another important change was occurring in the brain, though at first it was modest. Early members of Homo, such as Homo habilis, had brains somewhat larger than those of Australopithecines, but still much smaller than those of modern humans. The increase was not dramatic at first, but it marked the beginning of a long trend that would continue for millions of years. Brain size alone, however, does not tell the whole story. The organization of the brain, the complexity of neural connections, and the demands of social and ecological life all influence cognition. As environments remained variable and tool use became more common, individuals capable of planning, remembering, and learning from others may have gained subtle advantages. Body proportions also began to shift. Some early members of Homo appear to have had slightly longer legs relative to their arms, suggesting improved efficiency in walking. Endurance walking, covering longer distances in search of food or water, may have become increasingly important in the open and changing landscapes of the late Pliocene. This does not mean that climbing disappeared. Even early humans likely retained the ability to climb when necessary, especially for safety or access to food. But the balance between life in the trees and life on the ground was gradually shifting. The hands, too, were becoming increasingly capable of precise movements. The anatomy of the thumb and fingers in early Homo suggests improved dexterity, useful for manipulating tools and handling a wider range of materials. Precision grips, in which the thumb and fingers work together to hold small objects, were becoming more refined. These changes in the hand reflect an important shift in how hominins interacted with their environment. Tools were no longer occasional or opportunistic. They were becoming a regular part of daily life for some populations. Sites dated to around 2.6 million years ago show clear evidence of stone tool production, often associated with what is known as the Oldowan tradition. These tools were simple, flakes struck from cores, used for cutting and scraping, but their consistent appearance in the archaeological record indicates that tool-making had become an established behaviour. The presence of animal bones with cut marks at some of these sites suggests that early humans were not only scavenging, but sometimes actively processing meat. Whether they hunted regularly at this stage remains debated, but access to meat and marrow would have provided valuable nutrients, especially fats and proteins that support brain development. It is worth remembering that none of these changes occurred in isolation. Diet, anatomy, behaviour, and environment were all interconnected. A slight improvement in tool use could influence diet. A change in diet could affect energy availability. Increased energy could support changes in brain function. Behavioural flexibility could encourage further innovation. Step by step, small feedback loops shaped the course of evolution. Another significant aspect of the transition from Australopithecines to early humans was the increasing importance of cooperation. Obtaining and sharing food, defending against predators, and caring for young all benefit from coordinated behaviour. Social bonds, already strong among Australopithecines, may have become even more important as groups relied more on learned behaviours and shared knowledge. Communication, though still far from language as we know it, likely became more nuanced. Gestures, vocalizations, and expressions would have conveyed information about food sources, dangers, and social relationships. The ability to interpret such signals quickly and accurately would have been valuable in complex environments. There is also evidence that early humans began to expand their geographic range. Fossils of Homo habilis and related species have been found in several regions of East Africa, suggesting populations that were mobile and adaptable. Over time, later species of Homo would move beyond Africa, but in the Pliocene and early Pleistocene, the foundations of that mobility were being established. Mobility requires more than the ability to walk. It requires knowledge of landscapes, memory of water sources, and the capacity to adapt to unfamiliar environments. These are cognitive and social abilities as much as physical ones. The transition from Australopithecines to early humans was not a simple replacement. For long periods, multiple hominin species existed at the same time, sharing the same general regions but occupying slightly different ecological niches. Some specialized in certain diets or habitats, while others were more generalist. Eventually, some of these lineages disappeared, leaving only a few branches that continued to evolve. Extinction, as always, was part of the process. The fossil record preserves many species that thrived for hundreds of thousands of years before vanishing, often as climates shifted or competition intensified. One of the reasons early Homo may have succeeded is flexibility. A varied diet, increasing reliance on tools, and the ability to move efficiently across landscapes would have allowed these populations to cope with the climate pulses and environmental variability that characterized the late Pliocene. Flexibility is not a dramatic trait. It does not produce spectacular adaptations overnight. But over long periods, it becomes one of the most powerful forces in evolution. It is interesting to imagine what early humans might have looked like to an observer standing at a distance. They would not have resembled modern people closely. Their faces were still more projecting, their bodies smaller, their behavior shaped primarily by immediate needs rather than long-term planning. And yet there would have been something new about them. A way of moving across the landscape with purpose, a tendency to carry objects, to stop and shape stones, to return to certain places again and again. A pattern of cooperation and learning that hinted at changes still to come. The transition we are describing did not happen everywhere at the same time. Some Australopithecine populations continued much as they always had, while others began to show the traits associated with early humans. Evolution is a branching process, and the lineage that eventually led to us was only one of many. There is something quietly humbling about that thought. Our existence was not inevitable. It depended on a long chain of small changes, each one shaped by environments, accidents, and the simple fact of survival. As these early humans continued to evolve, their presence began to alter ecosystems in subtle ways. The use of tools, the processing of carcasses, and the movement of groups across landscapes began to leave clearer traces in the archaeological record. The story of human evolution was becoming easier to read, though it was still far from complete. And yet, even as new traits were emerging, the broader world of the Pliocene continued to change. Climates fluctuated, landscapes shifted, and many species, hominin and otherwise, faced the same challenges of adaptation and survival. Seen from a distance of millions of years, the Pliocene might appear to be just one more interval in the long history of Earth, another chapter in the shifting patterns of climate, continents, and evolving life. But when we look more closely, it becomes clear that this period holds a special significance in the story of our own origins. It was during the Pliocene that many of the conditions and traits that would later define humanity began to take shape, not suddenly, not dramatically, but through a series of gradual and interconnected changes. One of the reasons the Pliocene matters so much is that it represents a time when several crucial developments were occurring at once. The climate was becoming more variable, landscapes were changing, and early hominins were adapting to life on the ground in ways that distinguished them increasingly from their tree-dwelling ancestors. Walking upright, flexible diets, social cooperation, and the earliest forms of tool use were no longer isolated experiments. They were becoming established features of certain populations. Each of these developments alone might not have been enough to shape the future of our lineage. Together, however, they formed a powerful combination. Upright walking freed the hands. Freed hands made tool use easier. Tool use influenced diet. Changes in diet affected energy availability and behaviour. Social cooperation supported the raising of young and the sharing of knowledge. Climate variability favoured flexibility in all of these areas. What makes the Pliocene especially important is that these processes were still in their early stages. The beings living then were not yet human in the modern sense. Their brains were small, their technology simple, and their lives closely tied to the rhythms of nature. Yet the foundations were there, laid quietly over hundreds of thousands of years. Another reason this period matters is that it helps us understand how evolution actually works. It is easy to imagine evolution as a straight path, a sequence of improvements leading inevitably toward a particular goal. But the Pliocene shows us a different picture. Multiple hominin species existed at the same time. Some adapted successfully for long periods and then disappeared. Others developed traits that would later prove important. There was no single line leading directly to modern humans, only a branching network of populations, each responding to its own local conditions. This perspective changes how we think about our place in nature. We are not the end point of evolution, nor were we destined to appear. We are one outcome among many possibilities, shaped by circumstances that might easily have been different. The Pliocene also matters because it provides a window into how environments influence life. Climate pulses, shifting vegetation, and changing water availability created pressures that encouraged adaptability. Species that could not adjust often vanished, while those capable of flexibility survived and diversified. This lesson is not only about the past. It reminds us that life on Earth is always connected to environmental conditions, and that even gradual changes can have profound effects over time. There is another aspect of the Pliocene that is worth reflecting on. It was a time when the pace of change in our lineage was still slow. Evolutionary developments unfolded over hundreds of thousands of years, far beyond the scale of human history. The individuals living then would have experienced their world as stable within their lifetimes, even though, across generations, the landscape and climate were shifting steadily. This contrast between short-term experience and long-term change is an important part of understanding both evolution and Earth's history. Change does not always announce itself. Often, it moves quietly, becoming visible only when we look back across vast stretches of time. The fossil record from the Pliocene provides some of the clearest evidence of these slow transformations. Bones of Australopithecines and early members of Homo, footprints preserved in volcanic ash, stone tools scattered across ancient lake shores. All of these traces allow us to reconstruct lives that would otherwise be lost to time. Each fossil represents an individual who lived, moved, ate, and interacted with others, unaware that millions of years later their remains would help tell the story of an entire lineage. It is also during the Pliocene that the connection between behaviour and evolution becomes especially clear. Changes in how early hominins lived, walking upright, using tools, cooperating in groups, began to shape their bodies and minds. Evolution is not driven by anatomy alone. It is shaped by behaviour, environment, and the interactions between them. Another reason the Pliocene matters is that it marks the beginning of a trend that would accelerate in later periods: the increasing ability of hominins to alter their environment. At first, this influence was small, using stones to process food, moving resources from one place to another, but it represented a new relationship between organisms and the world around them. Over millions of years, that relationship would grow far more complex, eventually leading to agriculture, cities, and technologies that reshape entire ecosystems. But the earliest steps along that path began in the Pliocene, in the simple acts of picking up stones and shaping them for use. The Pliocene also serves as a reminder of how interconnected natural systems are. Geological processes such as the formation of the East African Rift influenced rainfall and vegetation. Climate cycles affected the availability of water and food. These environmental changes shaped the evolution of plants and animals, including hominins. Nothing in this story exists in isolation. Every change is linked to others, forming a network of causes and effects that spans continents and millennia. It is worth pausing to imagine what the world of the Pliocene would have felt like to those who lived in it. The sky would have been vast and unpolluted by artificial light. Nights would have been filled with stars, days with the sounds of wind, insects and distant animals. There were no roads, no buildings, no traces of modern life, only landscapes shaped by natural forces and inhabited by creatures adapted to those conditions. In such a world, survival required attention, memory and cooperation. These traits, gradually refined, would become the foundation of later human societies. The turning point represented by the Pliocene is not a single moment, but a gradual shift, a transition from one way of living to another. It was the period when our ancestors began to rely more on the ground than on trees, when tools began to supplement teeth and hands, when social bonds and learning became increasingly important. Without these developments, later stages of human evolution might never have occurred. At the same time, it is important not to see the Pliocene only as a prelude to humanity. It was a rich and complex period in its own right, filled with diverse ecosystems and species, many of which have no direct connection to our lineage. The world did not exist for the purpose of producing humans. We are simply one part of a much larger story. Recognizing this broader perspective can be both humbling and comforting. It reminds us that life on Earth has always been diverse, resilient and capable of adapting to change. As the Pliocene drew to a close, conditions were continuing to shift. The cooling trend that would lead into the ice ages of the Pleistocene was beginning to take hold. Ice sheets expanded, climates grew more variable, and new challenges awaited the hominins who had already begun to change in response to earlier pressures. It is easy, looking back across millions of years, to think of the past as a path that inevitably led to the present. We know how the story turned out. We know that early hominins continued to evolve, that the genus Homo appeared, that much later our own species emerged and spread across the planet. But if we step back for a moment and consider the Pliocene as it truly was, an open and uncertain time, full of shifting climates, competing species, and fragile populations, it becomes clear that the outcome was never guaranteed. The world could have been very different. Imagine the landscapes of East Africa during one of the drier climate pulses. Lakes shrinking, grasslands expanding, resources becoming scarce. A series of droughts lasting longer than usual could have reduced hominin populations to small scattered groups. A disease, a change in predator populations, or simply a sequence of difficult years might have pushed one lineage beyond the point of recovery. Extinction does not require dramatic catastrophes. Often it is the quiet accumulation of small setbacks, a few generations with lower survival rates, a few failed seasons of food, a gradual decline that leaves too few individuals to maintain a stable population. Many species in the fossil record followed exactly that path. They lived, adapted, and disappeared, leaving only fragments behind. It is entirely possible that the lineage leading to humans could have been one of them. If that had happened, the Earth would not have noticed in any obvious way. Forests would still have grown and retreated. Herds would still have moved across plains. Rivers would still have carved their channels, and climates would still have shifted in their long cycles. The absence of humans would not have left a visible gap in the ecosystems of the Pliocene. Other species would have continued evolving, filling ecological niches, adapting in their own ways. There were many other primates, many other mammals, many other intelligent and adaptable creatures. Evolution does not favour a single path. It explores many at once. Consider, for example, the possibility that another lineage of primates might have developed different adaptations. perhaps remaining primarily tree-dwelling, but evolving greater cognitive abilities suited to life in the canopy. Intelligence does not require upright walking, and the evolutionary pressures of complex social living and foraging could, in theory, have produced very different kinds of minds. Or imagine a world in which climate variability had been less pronounced. If forests had remained more continuous across large regions of Africa, the selective pressures favouring upright walking and flexible diets might have been weaker. Hominins might have remained more like their arboreal ancestors, adapting to life in trees rather than on the ground. In such a world, bipedalism might never have become the dominant form of locomotion in our lineage. Hands might have remained primarily tools for climbing rather than for shaping stones or carrying objects over long distances. Technology, as we know it, might never have arisen. There are also geological contingencies to consider. The East African Rift, with its varied terrain and changing lakes, played a significant role in shaping hominin evolution. If the geological forces that created this landscape had been different, if the rifting had occurred elsewhere, or not at all, the environments that encouraged adaptability might not have existed in the same way. Small differences in geography can lead to large differences in evolutionary outcomes. Even the closing of the Isthmus of Panama, which altered ocean currents and climate patterns worldwide, contributed indirectly to the environmental variability that shaped African ecosystems. Without that change, rainfall patterns might have been different, influencing vegetation and animal populations in ways that would ripple through the entire food web. It is remarkable how many factors, scattered across continents and millions of years, contributed to the conditions in which early humans evolved. Another possibility to consider is competition among hominins themselves. During the Pliocene and later periods, multiple hominin species coexisted. Some were more robust, others more gracile, some better adapted to certain diets or habitats. If one of these other lineages had developed more advanced tool use or greater cognitive flexibility earlier, it might have become the dominant branch, while the ancestors of modern humans faded away. The fossil record shows that this kind of replacement happened repeatedly among hominins. Entire species appeared, thrived for hundreds of thousands of years, and then vanished, sometimes replaced by closely related forms. Our own lineage was not immune to this pattern. It survived, but survival was never guaranteed. It is also interesting to think about how small behavioural differences can influence long-term outcomes. A slight tendency to explore new environments, a willingness to experiment with tools, or stronger social cooperation can, over many generations, create cumulative advantages. If these traits had been less common in early hominins, or if environmental pressures had favoured different behaviours, the trajectory of evolution might have diverged in subtle but profound ways. There is a quiet lesson in this. Evolution is not a story of inevitability. It is a story of possibilities, most of which never come to pass. The Pliocene was a time when many paths were still open. The beings living then could not foresee the future. They did not know that some of their descendants would one day build cities, explore space, or look back across millions of years to study their origins. They lived in the present, responding to immediate needs, finding food, avoiding danger, caring for their young. And yet, within those ordinary lives, the conditions that would eventually lead to us were taking shape. It is also worth considering how different the modern world would be if those conditions had unfolded differently. Without humans, ecosystems would have followed their own courses, shaped by natural processes alone. Many species that are now extinct due to human activity might still exist. Forests and grasslands would cover different regions, altered only by climate and geology, rather than by agriculture or industry. The atmosphere itself would be different, lacking the rapid changes caused by industrial emissions. Rivers would flow along courses determined solely by natural forces. Coastlines would still change, but not under the influence of large-scale engineering. Of course, such speculation is not a way of wishing for a different world, but a way of understanding how contingent our existence is. Recognizing that we are the result of countless small events and choices, of climate shifts, geological changes, and evolutionary experiments can deepen our appreciation for the fragile chain of circumstances that led to the present. There is also a certain quiet comfort in this perspective. It reminds us that life on Earth is resilient and diverse, capable of adapting in ways we cannot always predict. Even if one path ends, others continue. Looking back at the Pliocene from this vantage point, it appears not as a predetermined beginning, but as a crossroads, a time when many futures were possible. One of those futures led to us, but it was only one among many. After wandering through the landscapes of the Pliocene, after watching the climates shift, the grasslands spread, the lakes rise and fall, and the first upright walkers move cautiously across the ground, it is worth slowing down for a moment and letting the scale of it all settle in. The story we have followed is not a story of dramatic turning points or sudden transformations. It is a story of patience, of small changes accumulating over spans of time so vast that no individual could ever perceive them. Those early hominins did not know they were part of anything unusual. They did not feel themselves standing at the beginning of a new chapter in the history of life. They woke each day to the same concerns as any other animal: finding food, staying safe, caring for their young, resting when the heat grew strong, moving again when the air cooled. And yet, through those ordinary days, something extraordinary was slowly unfolding. Walking upright, at first an occasional behaviour, became a defining trait. Hands, freed from locomotion, began to shape and use objects. Diets broadened, social bonds strengthened. Minds grew more attentive and flexible. None of these changes seemed dramatic on their own, but together they set in motion a process that would continue long after the Pliocene ended. It is easy, from our vantage point, to focus on what came later. The growth of larger brains, the spread of humans across continents, the development of language, art and technology. But those later developments depended on foundations laid much earlier, in landscapes where small groups of early walkers adapted to a world that was itself constantly changing. The Pliocene was, in many ways, a quiet beginning. One of the most striking things about this period is how closely our ancestors remained tied to the natural world. They did not reshape landscapes on large scales. They did not alter climates or redirect rivers. They were participants in ecosystems, subject to the same forces as every other species: predation, competition, drought, and abundance. Their survival depended on awareness, cooperation, and adaptability, qualities that still matter deeply today, even in a world that often feels very different from theirs. There is something grounding in remembering that our lineage did not begin with cities or tools of metal, but with creatures who moved carefully through grasslands, listening to the wind and watching the horizon. If you imagine standing in such a landscape at dusk, the air cooling, the sky turning from gold to deep blue, you might see a small group settling for the night. Some climb into trees, others rest close together, the sounds of insects rising as darkness spreads. Above them, the stars appear, uncountable, brilliant, unbroken by artificial light. Those same stars still shine above us now, though we often see only a few through the glow of our own creations. Time, which seemed slow and steady in the Pliocene, continued its quiet passage. Generations followed one another, species appeared and disappeared, climates cooled further, leading into the ice ages of the Pleistocene. Early humans would face new challenges, new environments, and new opportunities. But all of that lay in the future. What mattered in the Pliocene was survival, one day at a time, one generation after another. The chain of life continued, unbroken, carried forward by individuals who never knew what their distant descendants would become. It is worth reflecting on how fragile that chain was. At many points, it could have ended. A prolonged drought, a shift in climate, a decline in population, any of these might have erased the lineage that led to us. That it did not is a reminder of how much of history depends on small, often invisible factors. And yet, fragility does not mean weakness. Life persisted, adapting to change, finding new ways to endure. the qualities that allowed early hominins to survive, flexibility, cooperation, awareness, are still part of who we are, even if expressed in very different ways. There is also something deeply connecting about this story. Every person alive today is linked to those early walkers by an unbroken chain of ancestry stretching back millions of years. Every heartbeat, every breath, every quiet moment of thought carries echoes of lives lived long before language, long before memory as we know it. The landscapes have changed. The species around us have changed. But the continuity of life remains. Perhaps that is one of the most calming things to consider. In a world that often feels fast and uncertain, there is comfort in knowing that life has always moved forward, slowly, patiently, adapting to circumstances that could never be fully predicted. The Pliocene reminds us that change is not always sudden or dramatic. Sometimes it is so gradual that it becomes visible only when we look back across immense stretches of time. And as this quiet journey through that distant epoch comes to a gentle pause, it is easy to imagine the night settling once more over those ancient landscapes, the sounds of insects and distant animals filling the darkness, small groups of early hominins resting beneath the stars, unaware of the long future ahead of them, yet already part of it in every step they took.